on my foreign language multicast tool that sends it also to YouTube, and it seems that I have excellent quality. So our internet is actually keeping up with all that. That's good. This computer is showing its age, and there are no options for upgrades here. What the? There we go. I should probably get the new version of Social Stream Ninja. That's probably a good idea. All right, so all that stuff's done. Oh, we don't need any of this stuff. Doink, doink, doink. That ESC flashing tool was very comprehensive. I was really impressed with that. And Momo has been returned to my buddy Big John, and Momo is out of here. There's no more Momo. He has to plug in all the rest of the plugs, put the blade back on, and do a little bit of the keyboard warrior stuff in order to get the ESCs talking. I think since we do flash an app to the ESC, I believe they'll probably speak, the same serial protocol and everything that the previous controllers did. And as we saw, they don't even begin to break a sweat when they're functioning. So those should be really good. He's going to wrap them in. He's going to put shrink wrap back on them, and that should keep them from like rattling themselves into a short. So we're back. We're doing a little Eurorack stuff. We're doing a little PCB design, a little bit of computer work. I need a fan on me because I'm always generating heat at just a concerning rate. Start sweating if I sit still for too long. And if I'm confident about this board, which I should be, I may order 10 of them instead of 5. We'll just have to see. The size limitations on the PCBs that I get for Eurorack stuff is that Eurorack is a little over 100 millimeters for the available PCB space if you have them, flat like this. In that dimension, and I can't utilize that because the $5 PCB deals stop at 100 millimeters. So if I can keep it to or under 100 millimeters, then I can take advantage of the PCB cheapness deals. Now this is a very simple design, and I put it together very quickly. We've got a couple top layer parts that'll have to go in first, and then I'm gonna have to put in 2 of the sockets and then whittle their pins down so they're flat, because the chip will go right on top of them. We almost got away with it. The Thonky Cons, they could be just a tiny little bit taller, maybe a baller. Maybe if they had a girl in the hood, they'd call her. The jacks we know to be good, right? Where's a thonk? I usually have a thonk lying around somewhere. It's probably on the other desk because I've got the other PCB design that we're taking all the parts from, and those fit. Those did just fine. Actually, Julian's using the other version of this. I should probably build one of these up for myself. This is a powered headphone amplifier that used way too many amplifiers. Way too many amplifiers. It's a little bit overbuilt. And then there were a couple mistakes on it. I forget what they are at this point, but I've largely abandoned this one. Oh, Pseudomaze. Hey, thank you for the sub. What's going on, Pseudomaze? This very minute? My God. Yes, 23 months. Thank you so much, Pseudomaze. We're going to do a little bit of PCB design, and this is actually a subject that I know a little bit about. I've designed quite a few PCBs in my day. With you guys on stream, we've designed quite a few PCBs. I mean, I've got them just within reach. The status lights on Burn the Subs are somewhat obsolete now, but we'll eventually get those up and running too on the actual Burn the Subs. We'll work on that. We'll work on that soon. I'm bringing that back. I wanted to get some of this Eurorack stuff done because I've been sitting on the PCB design for like 5 days. I got to a point where I'm like, well, only the fun stuff is left, so let's get all the fun stuff done on camera where it's more fun. Here's a flat one. This one was Osh Park. I actually ordered these from Osh Park just to see what their quality was like. And it's pretty good. Like, their small text is so much cleaner than Seed Studios. So much cleaner. Like, all this stuff is so much cleaner. With Seed, when you get into the larger, or sorry, the smaller, well, they're not so bad. I guess the text that I was seeing as blurry was really small. Like, that's crisp. That's fine. I don't have room for all those markings on this board. This thing is so dense. Yeah, it's like when you do some mechanical engineering projects, you're looking at like tolerances that are maybe sub-millimeter, maybe sub-millimeter. You're going into like one or two decimal places. And like if you have something like a DRO and a bunch of knobs, you can actually get a feel for that accuracy. And it's just like, wow, this is a lot. You go into a couple decimal places and now you're in unfathomable amounts of you know, granularity in your measurements and detail and tolerance. And then you design a PCB and it's like 10 times the detail. Please, Todd, no. It's like so much more detailed to like microns and like sub-microns and stuff like that. It's absolutely wild. And then the ability of, you know, printing and the etching and all that stuff is just incredible. Very, very crazy stuff. And this is like, this would be considered like big and clunky to a modern, like professional PCB designer, because these are like maybe like early 90s level of design. Whereas nowadays they're using resistors that are just too small to work with. They're too small for me to work with. Yeah. Fitting a trace between pads and it's like totally isolated. I can fit multiple traces between pads. The routing on this board was a trip. I'm actually kind of sad that we didn't end up using the design, and there's a lot of noise in these parallel connectors, or parallel trace runs, sorry. The parallel traces and possibly the amplifier design that I did is somewhat, well, it's very amateurish, because I am an amateur when it comes to, I'm an armature. I'm an amateur when it comes to designing stuff like this, especially audio stuff. I did my best. I did as good as I could do. And I think I did an okay job, but there's like a little bit of noise in the lines, and yeah, it's a little overly complicated. I mean, it uses two LM113700s, one there, one there. That's a lot. And then I use these little tiny op amps, and I tried to spec them properly, but it turns out they were a little bit too specialty, and so DigiKey doesn't stock them anymore. They're expensive. So this is a totally abandoned design, unfortunately. In the powered mult that we're making, we're using SO, what is it, 16, 3, 6, 9, 12, SO14 op amps. We'll determine which specific op amp I use later, but we're going to use SO14s, and they are, they're the big ones. The weird packages, they're like 40 cents each, as opposed to this one, which was $4, and now I can't find it anymore. So we're keeping our design big and clunky. I should sell the PCBs to Modular Addict or something. Oh, these aren't the rounded pads. That's all right. I tried to make everything like a little bit rounded for fun. No, not extra wide. These are normal width SOIC. As wide as the tip, but SOIC. No. These are much smaller. These are, I had one sitting over here. Yeah, these are tiny. They're this width, which is SOIC, which is obsolete. I mean, if this is hand solderable, and you can actually hook up lead wires to it, which is why why they're still popular. But quad flat, no lead, and then there's an even smaller package for these things. But Quad flat no lead are just those little square chips with conductive pads on the side. That would be the more modern chip, but I couldn't find like a cheap alternative to the TL074 that had that packaging. I don't know what's available nowadays. I should look at some point. But man, routing power and signals into all these circuit blocks was nasty work. It was nasty work. How do I do this? Oh, well, maybe if I go from here and then I bump this trace over, and so now I've got two traces going through there. Are those going to fit through the potentiometer leads? Can I get 4 of them to go through? Oh no, only 3. Look at how close that is. And I had to use the special pads. Maze Runner, yeah, it's something like that. It really feels like Factorio, to be honest. It's very Factorio-y. That's why I have 300 hours in Satisfactory. Look at that. Oh God, I gotta get this over here. I'll go down and around and then up and over. What do you mean there's noise on the board? I guess I could have bumped everybody up, but then I would be trapped behind this trace. That trace is going to there. And oh yeah, see, if I bumped everybody up, here, let me get a pointing device. So if I did this as what seems natural, to go up and over to here, it still has to go down here. Now, the fact that there's vias on both of those means I probably could have just passed it above and had this go over like that to where it needs to go. So that would have gone through here, and that would bump up to the top layer. It seems as though, well, actually, yeah, I probably could have just, oh no, but that blocks this trace from going vertically. Ugh. Always something. So instead, I round the bend, and go up and over. Although I could have cut it a little shorter here. I was trying to maximize the amount of copper on the lower layer because this thing gets toasty warm. This is a warm chip. I bought specifically a headphone amplifier for this one because Julian said he wanted it to work on headphones. I probably could have just calculated some numbers and put a regular amplifier on this, so it wouldn't have been such a weird thing, but I bought a headphone amplifier that had a suggested circuit in it, and we used it. It works. I mean, this thing works. It's just a little noisy. Why is it noisy? The alternative version of this one, the one that the British company made, that is better, doesn't use as many chips. It doesn't have all of the TLO, the 113700s. Probably uses a dual pot potentiometer to do the fading, to do the gain adjustment in and out. And it uses just one TL074 on the back of a 2 HP board. So it is indeed superior. It does everything Julian wanted it to do. It's just, yeah. I don't know. Sometimes you try stuff. It's very discouraging. You feel like everything's already been done. It's already a thing. Everyone's already doing it. That guy just made the circuit board you've been spending a week on. They did it in an afternoon. It's like, oh, okay, cool. Why isn't this on there? So I got 2 dogs again, so there might be a lot of barking in the background. I don't think you guys will hear it much, but when they get into something, they'll let it be known that a corgi is indeed barking. Get the soldering iron out of here. I want to get this board ordered. It's not that big of a deal. Like it should have taken me 10 minutes to design. We got the schematic down in about 5, and then, well, I'll go over it when I start, what the design process is for a PCB like this, because it's fairly simple. I kind of want to get started right now, actually. But I like this song. I'll let the song play through. I don't have a lot to talk about. Momo's gone. Big John is actually giving me money for that. I don't know why. It's just a little bit of soldering, but it helps him check a box, done. Momo works again. He just has to do a little bit of follow-up work to get it back on the grass. Apparently the neighbors would comment about how clean his lines are, because it's like, well, yeah, I have a 3D printer slicing program practically making all of these lines in the grass. It's really funny. Apparently those are popular overseas and they're becoming more popular here. And nowadays, I think you can just buy like a kit to put that all together, to put Momo together. It was a little bit more slapdash 6 years ago when he actually got Momo, sort of his pandemic project. So yeah, cool stuff. It was really cool. And it's really cool of Big John to give me that kind of job to do, because it's sort of a slam dunk for me. I feel like it's not even work. And he gets his vacuum cleaner fixed, you know? Sorry, lawnmower. Jeez. Why can't I get that right? Oh my God. Yeah, these pins on the DuPont, or sorry, on the thonks, the pins are actually not round. They're just little flat tabs. Lawnmower is just a vacuum cleaner for grass, but it doesn't bag. It doesn't have a bag. If it had a bag, I would believe you. So I get to get away with these tiny pads, these tiny vias. I can even make them smaller, but I wanted them to be give a little bit of wiggle room. But yeah, if I was really pressed to design something more compact, I could make these smaller within specifications. I like the oval pins though. They do quite nicely for space requirements. I feel like I've been hit by a bus. My allergies are so bad. I don't know why I have allergies at all. Possibly, I don't really think this is it. It's like a cat moved in somewhere in the neighborhood. There's a black and white cat that I've seen across the street and a couple houses down from us. I don't know where the cat is located specifically, so I don't think the cat is out there rubbing its booty against literally everything outside, but I have had bad allergies in my eyes the past couple days. I think it's actually just environmental allergens, but it really feels targeted. The cat would literally have to jump into my face every day when I went outside for me to have the same allergies that I'm having right now. But it is like, my eyes are terrible. Terrible scratchy eyes. All right, let me get the music out of here. Let's just get started. I'm just gonna start talking about PCBs. Yoink. All right, no more sad song. Hi everybody. Hello and welcome. Momo, I was just saying, Momo's gone. Momo's out of here. I'm, I guess, getting paid for what we did with Momo. That's nice. It's very nice of my friend to do. Big John has been a friend since college, 20 years ago. Oh my God, it's more than that. Ooh. Big John's been a good friend. We've done a lot of cool stuff. Stream is no longer starting soon. Yeah, see, it's gone. I just kicked my camera. It's gone. There's nothing there. You guys know me. You guys know me to design PCBs every now and then. And with all the Eurorack stuff that we're doing, Julian was complaining about the multi that I made. A mult. What is a mult? It's what your hair does when it sheds. No, a mult is just something where you plug one signal in and it distributes it. I don't know why they got to call it something weird. Why do they got to call it something weird? They call it a mult. Why? Just call it what it is. It's a distribution board or something. They got to make it sound cool. It's music people, whatever. I made this one and it's unpowered. This is on perforated prototyping board. It is 2 horizontal positions and I want to keep it that way. But the complaint from Julian was when he plugged multiple things into this, the signal degraded. And so if you have a 1 volt per octave signal, because we're running with plus minus 10 volts, generally assumed, even though they're plus minus 12 volt devices, plus minus 10 volt, what did you do, Haystack? Plus minus 10 volts is what all of our Eurorack signal stuff needs to be compatible with, whether it's audio, whether it's a control signal, which are typically 8 volts. We need our walled garden to remain walled, so if we plug the wrong signal into this thing, it doesn't blow up. So with those signals, they may be a lot of volts, but there's not a lot of current behind them because nothing is really designed to do work. It's just designed to represent a voltage level. You know, we're not moving motors, right? We're not lighting up significant lights. We're lighting up LEDs. There's not much there. So when you have your audio signals going out, they don't need to be super strong. They just need to be accurate, right? And so if you distribute it to a bunch of different stuff, you are adding things that your signal needs to go to, and you're adding like resistances and stuff like that to your line. And so your signal is going to drop down, right? As it distributes to the various places and only has so much current that it can draw upon in order to create those voltages. So Julian was noticing that there was a degradation in signal because, you know, again, we were just straight up splitting the signal. The response to that, the way to avoid that is you have a powered mult. This is a powered mult. Anyway, now that you know the schematic 100%, now this is a powered mult. Powered multi. In a schematic, generally you're looking from the upper left to the lower right in terms of your functionality. That's generally how it should be done. All bets are off. Listen, all of the sort of things that I say about how a schematic should go together, I'm an expert in this, but the problem is there are no strong standards. You will have something like a certain type of schematic should look a certain type of way, and then it should have a certain type of symbols on it, but nobody's governing, there's no governing body for that. You may have different standards for different organizations. For us, when I was working with the FBI, we had a particular standard for how our schematics were put down, and that was because not just experts were looking at them in order to glean functionality, right? So what I do is very similar to what they do. It's rigid and it has its own little style marks to it. And I do have reasons behind some of those, but others are just, that's the way I put a schematic together. So generally what I like to do is I like to have a labeled ground that's a hollow arrow pointing down. You should have ground signals always as the arrow pointing down and voltage signals as the arrow pointing up. And then in Elden Ring, you point down or something like that. I don't know. That's generally the convention, but it also is completely malleable. Different strokes for different folks. I have a negative voltage and I didn't feel right having it point up, so I have an arrow pointing down that is labeled V neg. It should probably be labeled -12. I just had this lying around in my parts, my Fusion 360 parts. All of these symbols are parts that represent hardware. In this case, in the +V, it represents a connection. So there is no physical hardware associated with this arrow. Instead, this arrow is pointing out that anywhere you see an arrow up with a V plus is going to be connected to each other. So all of these capacitors here, the chips, the capacitors there, they are connected to V plus. The reason we're doing it this way is there's a plus and a minus supply, and that gives you the full number line, and it allows you to utilize cheap hardware that's like not specialized to carry your audio signals and your other control signals around it. Basically standardizes the number line that we're working on so that we can have a walled garden. Dad tore an L-shaped hole in his leg last night and had to go to the VA. Jesus Christ. L-shaped? That's nasty business, dude. Well, hope everyone's okay, and I'm glad you're here. So yeah, that's what the arrow pointing down with GND, we don't handle any differently than arrow pointing up, right? Those are just associated with a connection between different pieces of the circuit board. What we're doing in the schematic is trying to communicate to another engineer or myself years later what's on the PCB, what physically is there, what parts are there, what connections are there. So our connections are just lines that go between things, and then in the actual PCB design, these symbols will pull in parts with those specific connections. So this symbol represents an amplifier. And so we label it TL074D, and that's labeled on the board U3, and then we have an A, which represents which of the 4 amplifiers inside of that integrated circuit we're using. This is one of those parts where we have a generic symbol and then it's not digital, so we have multiple of the same part inside the chip, so they actually let you split that up, and there's a way to make the part that lets you split it up. So we have gate A, B, C, and D, and you'll notice they have different numbers on the pins that represent what physical pin is outputting from, you know, the amplifier part from the positive sensing and the negative sensing leads. So I've been told by people like Julian that I need to like do a real low level explanation of what things are. And if this gets ahead of you, I apologize. I should probably write and make a definitive. This is a 3-stream watch streak. Hell yeah. All right, I should probably write a script and actually talk about some of the stuff that's going on here. This amplifier setup is weird. Now, this is a non-inverting amplifier, so we're going into the positive part of the gate. And then on the minus, we have a little feedback stuff going through C1 and R1, and R2 is going to ground. I did not make this up from nothing. If we look, this is an article that was on, what was it? It was one of those DIY synth sites. But compensation techniques for driving large capacitance load with high-speed amplifiers. So we're not particularly high speed. Audio's not high speed. Radio is high speed. Radio, you're dealing with gigahertz waves, which are really tiny and they act really weird. Radio has a whole bunch. Radio's like when you've been doing electronics long enough, you may start to get into radio and understanding what's going on, but it's not easy. That's the type of electrical engineering knowledge that I bring to the table. What's the value added of watching a bother stream? You get to listen to somebody prattle off about electronics basics while punctuated by fart noises. Why would you watch a bother stream? Why would you do this? What's wrong with you? Anyway, so yeah, the design is not mine, but the powered mult is basically a way to distribute our signals. And since the ThonkeyCon connector, that's what these J1s are, this is basically a side view. And it doesn't, your schematic symbol does not have to be exactly what the thing is. I guess just in audio, they've decided that this would be the way the connector looks. I probably would prefer something more like this, where it's just a symbolic representation. What J9 is, hold on. J9 is just, where is that? Just one of these. It's just a 0.1 inch connector. The weird symbol, the one that we were just looking at that looks like the side view of an audio jack, is a ThonkeyCon. ThonkeyCons are sold by thonk.co.uk. They are a Chinese part number. They have the part number on their listing. What you need to look for in a Thonk connector, because even I, in America, me in North America, order from Thonk. And they come in from England, and they're still the cheapest way, because Thonk buys these by the bushel, and you buy them in packs of 50. The important thing on the Thonk connector is that you make sure that it has this metal shoulder. This metal shoulder is going to take all the force of this thread and the nut that you thread into it, and it's going to save this connection here. All the way at the bottom there, you see how it's just cheapo metal that's been folded over, and that holds the ground tab in place, that tab right there. So that's held in place by that rivet. Without this metal shoulder, even just under hand tightening, you can extrude the threaded barrel portion through this metal plate, and then your ground drops off and your connector comes out. So this is very, very important right here. But you can see, look, there's a little tab in there. There's a little tab in there, and when the tab gets pushed out of the way by the connector, I'll do this without cutting myself, it'll disconnect from the other tab. So when you plug into this, not only is this spring here holding the connector in place and holding it against ground for the barrel portion down here, it is also disconnecting from a switch. Get the good cheap ones. Got it. Hey, don't come crying to me. Don't come crying to me. Don't you put that evil on me. You don't come crying to me when all your shit falls apart all over the place. Because that's what Julian and Dave do. They come crying to me when their shit falls apart and I have to fix it. And I fix it for free. So anyway, this is just a side view. So there's the barrel that's ground. When you plug the thing in, it moves this tab out of the way and disconnects this one. Schematics, you know, it could be that simple. It could be that intuitive. What the hell is that noise? Oh, lawnmowers. That was a weird sounding mower. I've never noticed that part. Yeah, they don't all do that, but a lot of them do. I mean, it's part of the spec of a headphone connector, but sometimes they don't have that switch. And basically, this switch is like from the 80s. It basically is a the basics of the basically. You can basically okay, semantic satiation. I have no idea what that word means anymore. It's 1980. You're wearing short shorts. You're sitting at your computer and doing individual vector programs in order to make your circuit diagram, or you're doing it with a stencil. And you want to have your boombox not blast music out when you plug headphones in. So the connector has two of these little switches for the right and left channel. You plug in your headphones, the two things physically disconnect, and your audio signal can instead go to whatever's on P3, whereas P2 goes to your speakers. It's the same way for barrel connectors that charge things, but you can also get barrel connectors without it. Parts are all over the place. Listen, when you design a circuit board, you get your parts together, and your parts have data sheets. And so the data sheets will tell you, like here, thunk. Yeah, well, thunk.co.uk. We're talking about it right now. Why does my dot not work? There we go. Thunk.co.uk. Best place to get ThonkeyCons. It's still the cheapest. As soon as it doesn't become the cheapest, I would order them from China by part number, but Thonk. I should actually look and see what PCBs Thonk has. Make a multi-order. What is this? What is all this? Hold on. No, this is function parts. And then we want jacks and ThonkeyCons. There it is. Okay. So parts have data sheets, and the data sheet gives you everything you need to know about the mechanical properties of the part. Oh, and here they're going over the design change is very beneficial. You can use a socket wrench. Well, no, not a socket wrench. You can use a socket, just a socket to give it that little bit of extra tightness. You don't want to use a wrench. That'll break stuff. Yeah, the ones with the white stripe down the side, exactly. So, yeah, here's a snippet from the data sheet from this part, and it gives all of the mechanical stuff, including, they do 1, 2, and 3 on that, but there's that symbol again. It's got the little hook, and then you got the little disconnect, although theirs is kind of weirdly placed. And then the where you should put the pins and what the distances are, a little rudimentary, but I think the actual part number is in here, yeah. Produced by WQP. What I did, oh geez, guys, sorry about the hiccups. I had half of a tuna sandwich for lunch, and I think the tuna is another big heart. I need to just eat salads, guys. I just need to eat salads from now on. Yeah, you don't have to take out the torque wrench. I've always wanted one of those fancy digital torque wrenches, but I've been relegated to the clicky ones my whole life. I do like getting out the torque wrench and using it. Maybe that's I don't know. There's like, I don't know what heritage I have actually from Germany. I think mostly Dutch is my family. Okay, anyway, they don't work at that low torque, but there's like little digital ones that you put in the path of the wrench and you could do the tiny, anyway, I went, like most of my parts when I'm looking for something to look good, I'm going to Thingiverse and I'm looking for a Fusion 360 part, right? Something that is compatible with Fusion 360, or not Thingiverse, sorry, something that was designed in Fusion 360. I actually go to GrabCAD, sorry, that was the wrong. Oh, I messed up my whole video. I'm giving you guys misinformation, me when I spread misinformation. We're going instead to Community Library, because GrabCAD was bought, the website and everything was bought by an additive manufacturing company. So they put themselves up there first. What GrabCAD used to be and still is a big repository of three-dimensional designs, from PCB components to like tanks. There's like a tank, there's probably multiple tank. Yeah, there's a tank. It's just, you can get, you know, a tank, or you can get a tank. There's all kinds of stuff. Anyway, so putting that part number in, it wasn't listed as a ThonkeyCon, but putting that part number in, you don't find a model. Thonk. Don't tell me I'm gonna find. There was, oh, Vactrol. There was one person that had a really good model of the Thonk. Okay, so WQP. Oh, here we go. That's the bad one. I think this is the good one. This is from, who did this? Muke? I don't know if this is the good one. I'm not sure. It does have the crappy one that explodes. Why? It's like armored. Why does it have armor? Huh. I wonder if these connectors are like particularly noisy. I don't know if this is the 3D model that I got. I had a different one. But in Fusion, you can actually add a part to a two-dimensional pad design. There's three pieces of your parts in Fusion. One is the schematic symbol. One is the pads that actually physically describe where the solder mask keep outs are, you know, how to define what that part looks like and the pads you're going to be soldering to. And then there's the icing on the cake is the 3D model of the part. So I will often go to GrabCAD. Sorry, wait, did I close the GrabCAD window? I did. I will often go to GrabCAD to find a good 3D model for stuff. This one doesn't show the, oh, it does have the part number. PJM301M, 3.5mm stereo, 3.5mm jack, 3mm jack socket, PJ301BM. I don't know if it's the P301M12. There was another 3D model. I don't think this was the model that I used, so. Maybe it was. Maybe it was. Maybe it's the, oh wait. Yeah, that's gets us back to Thorsten. Thorsten Thursdays. Maybe it's BM. Doink. Maybe not. Okay. All right, anyway, that's where I'm getting a lot of this stuff from. You can also generate parts in Fusion. You can generate the 3D model for the part in Fusion, because stuff like ICs are so standardized that it would be a nightmare to make this in Fusion just from nothing. Instead, what you do is on a little helper window, you put all of the dimensions from the datasheet and all the tolerances for the dimensions, and then it'll auto-generate a pad under your part. Making a part and getting your little library of parts together is a nightmare. It is an absolute nightmare. I've done it before on stream with you guys. I will do it again. The important part is I got all of the parts for the stereo mixer that never was to become because of a couple choices that I made for hardware that was a little too eclectic. Using generic parts, I can make a much cheaper version of this, but I'm not going to do that, because you can literally get one for like $50 from a UK company. So this is dead design, but what this design helped me do was pull in all of these parts and dimensions that I can then use to make something like a powered mult in a couple days. It's taken me more than a couple days, but you know, I'm trying to get through the basic explanation of what we're doing here. So these symbols represent three things: the symbol, the two-dimensional drawing of it, and then a three-dimensional representation of it. What you do when you put the schematic together is you keep functional symbols sort of in the same place, right? I move power out to its own thing, and following an Emily Gillette convention, I'm putting the power pins for the ICs over here. Sometimes I will open up the design a little bit and have them coming directly off of the first one of the amplifiers, just because that's the convention that you see. A lot of this stuff is monkey see, monkey do. I see other people doing it. If I think it's clean and it's a good idea, I will do it too. I like to leave a little bit of room for the wire to actually be represented instead of going directly into the sides of pins. That makes my designs kind of spread out a little bit more. Spreading out and having plenty of room for annotation and stuff like that is really important in a schematic. But this is in Fusion 360. This is not necessarily the schematic that I would publish. This schematic represents what connections are to be made on the circuit board. Now, it does double as a functional schematic now because, you know, whatever, but sometimes you could have stuff represented in a different way, specifically so that the program knows that things are connected in a particular way, and maybe represent it differently in sort of the published schematic that would be representative of your design. So anyway, blocks that look like things that we've seen before. That's sort of a standard convention because we are trying to use this to communicate what is on the PCB. So the article that I followed for this amplifier design, after researching and looking up, modular synthesizer, powered multi, I found a bunch of discussion about different circuits, and this one is a non-inverting in-loop compensation so that basically large capacitance load with high-speed amplifier. So large capacitance load can be handled with this design, and this explains what's going on. And I read a little bit of it and I said, oh yes, and then I immediately forgot everything that I read. I don't know what this is doing. I don't know what this is doing. I don't know why this is here, or what this is doing, or what these are. Actually, I do. This is the load. This is representing the load. But then we've got this capacitor feedback for high frequency snubbing, and then I don't know, something about putting a resistor here makes it do stuff better. Anyway, that's what I'm doing. I'm following that design, and I've got values for these parts from the modular synthesizer people. So generally in a design, when you figure out what circuit structure you're going to have, it'll behoove you, I use that word over and over again, to put it on a solderless breadboard before you actually commit to designing a PCB. And so this is the mixer. This is the 2-channel stereo mixer. Technically 4-channel, but it's 2-channel stereo mixer design that I put together on a breadboard just to test it out and make sure everybody was happy. I didn't do that for the powered mult. I don't think I need to, because the design of the amplifier is pretty much set in stone. When we put it together, maybe then I'll go to solderless breadboard and put it together and make sure that all the parts are right. Because right now I'm not assigning values to anything. I don't need to. I just need that connectivity programmed into my CAD program so that we can go to the 2D design, and you can't see them because I've finished this part of the design. But let's say I get rid of this one here. There's what's called an air wire. And this is an air wire, and this design used to be full of air wires. These air wires form what's called a rat's nest. You can have it auto-generate the rat's nest. It's generally going to go to the nearest pad, not the nearest trace. And you start out with all of your parts piled up in the corner. What I've done over the course of a couple days, really it was just an afternoon of concentrating, but I put together functional groups out of all of my parts. So the IC is in the middle. We're very constricted in terms of horizontal space, and our vertical space is vast and weird. I put together functional groups, like here's all the power stuff and the power filtering. Here's one set of 4 amplifiers. We've got the LED amplifier here, and then here's one of the channels. Oh yeah, one thing I didn't mention is the setup of this is so that if you don't plug in one of these, that little bypass sends it to the other bank. So if I plug one input into this device, I can power 6 outputs with the same signal. That's all that's doing. That's what that crossover is right there. So yeah, on the powered mult, we have a certain number of sockets that I need to include. Oops. Certain number of sockets that I need to include, and we have literally no space for anything else. So using some of the CAD tools, I was able to space out the 8 connectors evenly, and it's going to be the same thing as the unpowered mult. Plug in here or plug in here. If you only plug in one of these, all 6 of these will be the same. And then if you plug 2 of them in, you can have 2 separate signals that are distributed to three outputs. I'm gonna make a bunch of these, by the way. So the design of the amplifier was relatively simple. It has a few parts, but not too many. I put them together in functional groups and I started rearranging the parts until it made me happy. This actually does not make me happy right now. I need to move. I don't know. I feel like I want to swap these two, but I don't really need to. But it's like this trace here could be shorter. It doesn't need to be a quick little jump over. It's okay that it's doing this because this one's coming from over here and it needs to go to the one that goes to ground anyway. So it's like, what do you do? I could probably have arranged these to, I don't know. I debated the arrangement for a while. You basically organize your structures in your different functional groups until you see the rat's nest wires not overlap one another in weird ways. So that's how I designed it. And I approached it from like piecemeal, like start with one cluster of 4 because the other cluster of 4 can be exactly the same layout. These two are the same. I probably could have cut and pasted them if I wanted to. I think I copied them just by taking a screenshot of it. So you put your signals together and you make functional groups like your amplifiers, and then you wire them up to the actual sockets. And that was kind of a difficult thing. Things had to get a little bit bendy around there. As you're going, you're going to need to rip up your designs multiple times and put them back down. I didn't technically really have room for the decoupling capacitors, so instead I put those on the top layer. So those are going to sit between connectors. And these connectors are big and plastic and they're low temperature. They cannot handle soldering temperatures much. You can barely solder these pins before the connector starts to melt. So what I'm going to have to do is install these caps first. Then on the same side of the board, I need to install the connector. Then I need to cut the pins of the connector short and use a file or something to make it flat as flat as possible without damaging the board. And then I can solder the actual amplifier chip to the other side. And it has to go in that order: caps, connector, amplifier. And that'll seal in all the juices. So that's okay. So PCB design, everything is thrown into the corner. You can highlight components or structures by highlighting them in the schematic and then jumping over to here. And now I can move that cluster because it's all selected specifically. Using that method, I was able to get the different amplifiers into different groups of parts and then rearrange the individual parts until I was happy with the design. I can't eat salads. I like fresh lettuce and spinach leaves, but it hurts my guts. I thought salad was one of the most, it's like crunchy water. I thought it was like totally inert. That's terrible. Never heard of that. Although we technically can't eat salads here either because it's gonna make you poop to death. That's the reality we're in right now. What are you doing? Oh, I'm just spreading misinformation on the internet. Yeah, it's basically, for aesthetic purposes, I actually moved this cluster of amplifiers down to the bottom of the board, and I put the power supply in the middle. It is very difficult to place something like this. It looks like I did something very similar to what I did on the mixer. No, we want this. There you go. Looks like I did something very similar to what I did on the mixer, which is to put it in the middle and have it straddle. Oh, but I didn't utilize that. I didn't utilize it straddling this. These are for tantalum capacitors. I don't know if I really want to use tants. Tantalum capacitors are very sensitive to voltage. You can get them in 25 volt flavor, and I think I do have them. But basically, it's just the biggest capacitor that I can afford to put here, just to stabilize all the energy draw. So if you have a sudden signal that jumps up and needs all these voltages, these can just supply it quickly. This are a little irresponsible, but I did include them in the design. They've got their own little paddock down here, and they've got the capacitor junction with nice big thick traces going to everybody. So after organizing things into functional groups, getting them together, putting them in a place that's pleasing on the board, that is close to the signals that are going to be feeding the amplifiers and outputting from the amplifiers, I was able to get this circuit structure made. It's a lot like playing Factorio. At that point, once you get all those signals routed, that's when I go and I do power. Power can take a little bit more of a circuitous route to get to what it needs to go to. Signal lines, you want them to be short and direct and crisp and nice. You can't always get what you want, but the power traces I want to be as large as possible given the amount of space that I have on the board. So it goes small functional groups, inputs and outputs, then power, then ground. Because ground is going to be a plane. Ground is just going to be the shield around everything on this device. And so we are going to rely on a flood fill in order to fill them in. There's a particular kind of thing that we're going to place down in just a minute here in order to make all of our ground lines. So power is V negative, V positive, and then we ignore ground. I've turned off the air wires for ground so they're not all over the place because those come last. But the power can take a bit of a windy route. In the case of this powered mult, we don't have a lot of stuff going on. So basically their V plus and V minus just have to be routed to the chips and then the capacitors and stuff. So that made it relatively simple. And of course, I am using Schottky diodes to protect this circuit. I do not want it to blow up. It would probably blow up if I didn't, because I'd hook this up wrong, because this is just one row of pins and there's no keyway for that. So big, thick, nasty traces that get a little bit smaller as we get out to the various functional things so that I can sort of weasel them around things and get them to go to stuff. And I probably could have made that a little bit more symmetrical and cool looking. I just decided to do it this way. It's just get it done, get it done, get it done, get it done. A lot of the times with like designs like this, it's the time. Time is the biggest enemy to a clean, neat, and functional design. So that's the story of the first part of the board. Now, since I've routed all the power and I've not done ground yet, that's where we're at. We're going to do ground, then we do our markings, then we double check, and then I'm ready to order the board. There's not a lot left to do. I just wanted to show this part of the process. So, top and bottom. If you guys haven't noticed already that we are a top, no, wait, no. We are looking straight into the board, and our top layer is represented in red, our bottom layer is represented in blue. The little hatched out pieces here are the solder mask. The solder mask just defines where we do not put this sort of, I don't know what it is. It's not polymer. What is the coating made out of? It's like a shellac or something. The little coating that keeps our soldering iron from soldering to everything in its path. The solder mask is that what makes it green or purple or yellow. It's the like nail polish type coating. What's up? Michael Manog. So yeah, the solder mask, that's what that little hatched out thing is representing, is where the solder mask and where it's not going to put that solder mask. And that's what defines our pads and our pins and our vias and our whatnot else have you. And then we have a mechanical representation layer, which are these lines. I don't think those are in the silk screen. Some of them are, some of them aren't. Yeah, like, I guess this symbol is probably a full-blown chip, but in the mechanical, it shows that rounded looking chip. This is beautiful. Ah, thank you. I appreciate that very much. Like, okay, so that actually is the solder mask layer, but sometimes you have other mechanical representation of components that doesn't come through to the actual thing. And, you know, we can display all the layers as we see fit. I can also flip the board. I can hit just the letter F to flip the board. How do I put that away again? Oh my God. Fusion thinks I have all of this horizontal space, and I guess I do in this design. This design, I kind of do have all the horizontal space since it's such a thin board whenever we do these 2 HP designs. I like using curved traces, you know, take it or leave it. It's another thing to worry about. A lot of PCB design, at least on this level, is aesthetic. A lot of it is just making stuff look good. You can get down to the nitty-gritty of how all the magnetic fields are flowing around your board and stuff. Try to optimize things for that. But generally, I'm just following it like this because of an aesthetic. Also, space restrictions are pretty crazy. So that's why the design looks the way it does. And then as an added aesthetic, I do the curved traces. Those are uniform. It doesn't look uniform. So we need to put a ground plane down on this thing. I don't need this to be here. I wish it would collapse a little more easily. Is that what that button does? No, that's inspector. It's like, please let me put away the tool. Let's see. Nope, that doesn't do it. What did I just do? I added a layer. Layer 158. Yeah, I think layer 158 can go. Yeah. Wyatt thought I wanted to work on layer 158. Collapse dialog there. There we go. Okay. All right, so we're ready to put down a ground plane. Are there still secrets in PCB designs? Do you mean Easter eggs, or do you mean actual secrets to designing a PCB? Because there really aren't. There are no special secrets to designing a PCB. There's a couple little conventions that you generally try to follow, but none of it is forbidden knowledge. I don't like this. I don't like this, but I gotta live with it. I guess it's fine. These are the LEDs. Instead of doing one LED that would flip from red to green, I did two. One is red, the other's green. So one will light up or the other will light up when the signal goes positive and negative. Like a secret sauce? No. There's nothing secret. These are basically just sitting on the output of an amplifier, and then R10 is there to knock down the amount of current that's going through so that there's very little current from these LEDs to ground. When this goes positive or negative, it'll flow through the diode to the neutral ground, which is in the middle of our two voltage values, plus and minus 12 volts going into everybody. So this will generally see 10 volts max, but it may see up to 12 volts, and I think the TL074 can do that. I'm not sure. But anyway, those are just there for display, following another Emily Gillette design. And then I split it into two in order to just be a fancy boy. Okay, so ground planes. What we need to do is we need to do a polygon fill. So polygon pour, and I don't care about what it specifically is, but the signal name I want, oh, you guys can't see that. The signal, okay. Move the whole program and it turns out. My polygonal pour, oh, there it is. Okay, polygon pour. Signal name, GND, it's dynamite. So we're calling it ground. I don't care about the corner style, we'll just do flat corners on it. Fill style, we don't want a hatched fill, we just want a solid fill on this one. I do want thermals. I gotta stand up to see what the symbols are. Yeah, those thermals are fine. It puts a little... Thermals are when you have a pad and you need to solder it and you need heat to go in there in order to melt the solder. Thermals are a thing that motor controllers may not use very much, but in our case, this ground is not carrying a ton of current. We need it to connect to our vast and extensive ground plane. It's like tiny little ground plane right here. But anyway, we need it to connect to our ground plane. And so we add a thermal pad, and that puts 4 little hatches. It would be a 4th here if there was ground plane there, so that we can get heat in there when we solder it. They're nice to have. You kind of want to have them. Otherwise, you will bleed all of your iron heat away. So these 3 pins are ground, and they are thermally coupled with that. Now, this is a very thin line. You could maybe thicken it up if you want, but I don't feel a need to do that because we're talking about modular synth levels of current. We're not really doing any work. We just have some power there. Okay, so polygonal pour, orphans. I guess I'm going to leave orphans out because when you leave orphans out, orphans mean pieces of the ground plane that don't connect to anything. We will be putting what are called vias in order to get rid of the orphans. And so if we want to see the orphans, you leave them unfilled. Otherwise, this will add a bunch of little islands that we need to connect. We're going to do that anyway, but I think this is the best way to do it. Show the fill. You can hide the fill so that you can see the design cleanly like this. And by the way, vias are just plated through holes that have a pad on them. And they're designed to carry your circuit connection to the other layer. If you have multiple layers, if you've got like a 4-layer board, there will be a layer sitting underneath this. And so you'll see things like what are called orphaned vias. So on a 4-layer board, you'll see something that looks like this, but it's got a circle around it because it's not connected to that plane, and it doesn't look like anything's connected to it. And what that's doing is it's routing a trace on the inside layers of the board. So you can tell this is a 2-layer board because it doesn't have any orphaned vias. Now, when you look at a board and you see orphaned vias, that does not mean that it's a 4-layer board, because there's no distinction between a 4-layer board and a 6-layer board. You just know that if you have an orphaned via, you've either got something that the designer missed, or you have more than 2 layers. You can't look at the side to tell. You can't do that. It doesn't work. It doesn't work. All right, anyway. Let's pour some copper. Now, what I do... Oh, thermal width, fill width. Yeah, I guess we're okay. And then isolate. I guess I can change those settings later. I can take a look at what it does. What I do for fusion, because it'll represent as a dotted line, I keep tabs. So when I draw my ground plane, I make a tab and then draw it way out of bounds. Oops, wait, it's doing corners. Hold on. Oh, Control Z gets you out of the tool. Weird. Okay, so this is doing corners, so I want to be aware of that, like that. And then this goes way down here, way out of bounds. To there. Enter? Nope. Okay, that's not the double click, I guess. I don't know. Try that again. Bottom corner. Tab it. Down to here. Double click. Signal name. Oops, GND. And that floods our flood fill. And we can see that we've been very bottom layer centric for this entire design. So there's a big ground plane on the top layer because there's not a lot of traces on the top layer. I mean, I would keep this down to 1 layer if I could. And here's a big orphan right there. There's a big orphan just sitting right there. Look at her. Ah! I just scratched my nose and a moth flew away. Wait a minute, what is that? Wait, what does that say about me? Wait, what the hell was that? I just went like this and a moth went straight out of my beard. I shower in the morning. I take showers. I'm not like a dusty old man in a cottage in the middle of the woods. Although that it does have its appeal. What the hell? Okay, so that's our ground plane for the top layer. Now we're going to put the bottom layer one down. So we go to bottom layer with our little layer select tab over here. And same settings. And this time I put the tab right here. Oop. You right click, by the way, to change the... Why is that not changing when I right click? Huh. I'm going to close this tool and open it again. Did I just hear a cat outside? GND. And then this tab here. Yeah, there, now it's doing it. It wasn't doing it before. When I right click on the mouse, on the 3D connection mouse that was sent to me for free. By the way, my copy of Fusion 360 is being funded by AutoCAD. They're supplying me with this copy under the premise that I do a hashtag AutoCAD ad every couple of months. That I do a couple of these streams every couple of months where I just do what I would do anyway and use their tools. But I'm trying to be super basic about the explanations that I have here, because some people are mystified on how to use CAD programs, and they've all got their own special little weirdnesses. So in that program, 3D Connection was like, hey, you guys want like our wireless mouse thing? I, of course, plug it in because I'm too lazy to charge my peripherals. and it generally keeps it associated with this computer and everything, and it's faster. The only problem that I had with the mouse is that it's got a center click. I'm old school, but I'm not that old school with computers. And because my computer is 500,000 miles away from the actual mouse, it's a little slow when I use it wirelessly. I could probably plug a little Bluetoothy John into this, and then it would speak with the mouse better. But again, how many peripherals and accessories am I going to put on this computer? Look at all that USB. And then it goes to USB-C, which goes all the way back to the computer. All powered hubs, but the camera, the mouse, the Stream Deck, the keyboard, all that stuff goes into the one hub. And then that goes into a USB-C hub because this thing is super duper resource intensive, and the Logitech camera is super duper resource intensive. I need to bring all the camera connections into their own thing, but that's expensive. That stuff costs money. Anywho, so ground plane. Yeah, AutoCAD provided me with the copy, and they provided me with the contact with 3D Connection, who provided me with a free mouse, and I, of my own volition, decided to use it on this computer. They did not stipulate that I had to do anything like that. That's just me being, liking their product. This is annoying because it makes me do another line here, and I can't just, end it. But what happens, I guess if I mouse over it as much as possible and double click. Oh, that closed it for me, and then it's got that. But if I hit done, I'm afraid it's not going to connect. You must enter at least 3, wait. Oh, okay, that did connect. Okay, I didn't know it did that. That's good. Hopefully there's not... Whoa! Raid! We got the raid light going. Code rushed. Thank you for testing out all of my peripherals to make sure that they still function properly. I love that. Eventually we will couple that with something like a siren. Code rush, thank you for the raid. What's up, Lawn Dog? How you doing? We're doing some basic PCB design stuff. I'm finishing up a design, and so that gives me an opportunity to kind of go over some very basic circuit board design. This is the fun part. Doing the ground planes is really fun. The reason that I do the tabs like this, it might be kind of obsolete now. I used to do it with tabs because it was hard to click into the different layers if you did them right on top of one another. But now you can just make them a slightly different size or shape and get to all the stuff. So that's our bottom layer ground fill, and our bottom layer ground fill has to weasel its way around a lot of different structures. What we can do now is we can take a via and copy it. And so I'm going to put it right here out of bounds. Click done. There's an air wire because that's still associated with N27, which is this trace right there. So what we do, right click, properties, and we make that into a, well, I could also use the change tool to change it, but all the way down here, the name is N27, which is auto assigned. We make that GND. Yes. Could not merge the nets. Okay. I could also do it this way. This is my lazy way of doing it anyway. Take our power plug. Oh, I guess it tried to merge the nets. It didn't try to make a specific... I can't get out. I can't get out. I'm trapped. Help, help, help. Oh, we need to adjust this a little bit. It looks like that should be making a connection. I don't know why it would do that. Okay, let me just go somewhere where there's not a lot of stuff going on. I can't see the top layer from here, so if I center click, it'll put me into a via. I'll click that right there. Okay, so now I can just delete that stuff, and then I'm left with the via that I want. The via tool might do it too. And let's just check. We don't want any sort of air wire hidden is fine. Not locked. Auto diameter. Drill fine. Shape round. Ground. Don't know about that. Huh, it's funny. I don't have like an air wire setting here. Oh, solder mask. So I can not solder mask it, and then it would just look like a little dot on the board. I like to solder mask them because I can use those as ground, like with probes, I can use them. So I generally leave them uncovered, but you could have them covered by the green solder mask in this case. Like that wouldn't look so out of place. There we go. Jeez. Words are fun. They don't work. Okay, so now I'm just gonna cut and paste this all over the place. And then that'll tie our grounds together and make us a nice little shell. So let's go top to bottom and let's just start placing these. So first things first, we've got an orphaned plane. So I will bring this into that, and then bada bing, it fills in the rest. So it's no longer an orphan. Now, since this is kind of a big area, I'm gonna put 2 of them in, just like that. Why do I do it like that? Well, I'm not gonna staple these together. I'm not gonna put 10,000 vias on it, because I mean, it doesn't need to carry current. All it needs to do is shield a little bit from our signals. So just having them in, you know, the corners of a big plane should be fine. That should be fine. There's of course a giant plane. I mean, this is the unbroken red. It only breaks down here. I can't put one here because that would interfere with the ThonkyCon. That's what that big keep out in the middle is. So let's copy this again, and I'm gonna put one on the other side of the signal here. I'll put it, yeah, somewhere around there. And that just helps tie the ground planes together so that you've got, you know, all your things, your electrons, your pixels, your pixies, I don't know what you want to call them, but it makes sure that they're all there. Put one right in the middle. There is no right in the middle. Huh. All right, alt spacing. Hold down alt and you get your alternate spacing. This one I set to 0.1 millimeter and 0.01 millimeter. And if you stick with that and your parts are designed in that, then it makes laying out more of a grid operation. It's a lot easier to have consistency. Of course, I didn't even bother to do like aesthetic consistency on some of these things. Like if I move I really, like if I swap these two, something, I don't know. I spent a bunch of time like rearranging these and getting them to be in the right order. And I think I still see things that I could change, but they're not that important. So, but yeah, let's drop one of these over here. This one is on my alternate spacing, so it might not, yeah, it doesn't quite go in the middle. Put one there. I'll put one in here. And then I want one here just to tie it all together. So again, I'm just like peppering this thing with these vias. I don't think I can get one in there and be pleasing, because I can't get close to the edge of the board, and I don't like the prospect of this sitting on top of the LED. I don't like that. So I guess that's gonna go unshielded. Actually, here I think is okay. Yeah, that should be okay. And make sure I get all of my board locations. And you look for things like antennae, like this is an antenna here. So I want to make sure that I get a ground nearby it so it doesn't become an antenna. That sort of just breaks it a little bit and makes it into something else. I mean, obviously, in the grand scheme of things, it probably still is an antenna, but that just kind of helps this to not be a problem. Would be nice if I could get one like at the end here, but that's not totally necessary. We are talking about audio. This isn't like high frequency radio. And is there a demonstrable difference between doing all these vias and just leaving it? I don't know. Probably not. Probably am not doing a whole lot for my circuit here, but you do what you can. I don't know. I don't know if I really need that. I'll do it anyway. So come back over here and just staple that one together. I've had boards where I've had to like go all around the perimeter of the board in order to put vias at an even distance from one another. I think instead of that one there, I'm actually gonna Oh, not copy. Get out of the copy tool. I think I'm just going to put one here, just in the middle of that big block. And then we've got our IC underneath. So let me get this one here. And then, yeah, we'll just hit the edges of the thing. That, ugh, that's hideous. Don't like that. And I can't really get one in there unless I push this actual piece of the circuit over, which I don't really want to do much of. I mean, you can, but this isn't a satellite. You know, we don't have to treat it like one. That's all I can do. These things used to be expensive. You used to have to pay for each one of these vias. Those days are gone. You have like, you could put like 1,000 of them in, and then they'll go, well, actually, you should probably pay for those now. But, you know, it's not like that anymore. I can pretty much just freely throw these down, and the software will be like, okie dokie, and just do, you know, let me do this. I don't think I can get a via in here, and it, you know, I could move that up, and then I would be able to get a via like in this space, but I don't see it as entirely necessary. Again, this powered mult is going to be taking frequencies up to and including audio, but audio's not all that, it's not all it's cracked up to be, man. It's not all that difficult for this thing to carry those signals. I don't like it, but technically it works. So I'm gonna put, oh, yep, no, it doesn't like it either. We're out of our designed distances. That's what that little, hey, Dutch Mania, how you doing? See how it's blue? It's got the little blue mark up there. That will come up in the design rules check as a fail, because technically this is too close. So I am deleting that one. I said. There it goes. Okay. We're going light on the vias here. Light on the ground stitching. Try not to overdo it. If you put too many of these in, it becomes a real pain in the butt to solder. What is that? What am I looking at? Oh, I see. Yeah, that probably needs 2, but I don't want to bust up my V- trace. Yeah, that's probably fine where it is. How about you? What are you working on? We're finishing up this circuit board, and so I'm showing you guys some of the slightly fun parts of the PCB design, which is peppering it with vias and stapling our planes together and doing putting a meme on it or something. Oh wait, did I just? Oh no, that's not, okay, that's not violating anything. Good, good, good. Yeah, that'll tie this together. Give me a little shielding action. Okay, let's get one in here. And then this is a big flat thing that I can't really get into. Those are too close together. And that, I probably can't sneak one that close to the edge of the board. So I guess I gotta leave this. We can get another one down here. If I really want to sneak one right there. Yeah, just right there like that. That should be okay. Everything looks so much different in the CAD software. It's just way different. I don't need to put vias on this because this is the via that carries it to the other locations. Some of the settings are a little weird for the keep out stuff, but I'm trying not to draw out the design of this board, so we're going to just keep moving. But yeah, the ground pin itself is actually providing us with that connectivity, and it looks like the primary lion's share of current flow is going to go around this pin and then to the ground. So that'll go up and around. So that's okay. It's not great, but it's okay. I will, however, drop one right here, and it looks like I still probably can't get to the edge of the board there, so I'm not going to do anything with that. Dropping them down, using the copy tool. Technically, I would like to get one here, just to kind of break up this weirdness and pull it all together, but I kind of can't. So I'm going to go down here. That's right near the ground for that. That should be okay. Yeah, nothing there. Good. And then additional grounding. Yes, yes, yes. We want that because these are our big capacitors. What for smoothing out our voltage signals. And then I'll pull one up to, I can't go under the ThonkeyCon, so we'll just go there. And yeah, that. Yeah, let's hit it right there. Good, 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 good. Mostly I'm operating off of vibes right now, but it is a necessary component of the board that all of these grounds are associated with one another. And again, we've got a via right here, so that counts. One over here. Our ground planes are starting to get larger as I get to areas of the circuit that were easier to design. So we definitely need one right here. That overhang I don't like, but I can't do anything about it. This mess right here is something that I would like to put a via on, but I can't. So I will just go right here. Take one over here. And can I fit? No. Looks like I can't. I'm real careful. Nope, don't like it. So I guess we can just leave that. I could move that little swoop, little swoop-de-whoop. Nah, it's not. I'm just gonna leave it. It's fine. It's fine where it is. That's okay. We're okay. It's okay. It's fine. It's not gonna bother me. It bothers me immensely. I will not be able to sleep at night knowing that that's there. Whoop. That was a mistake. That was the last big mistake you're gonna make. Okay, that's fine there. Again, I'm going off of vibes. At the speed of the signals that we're dealing with here, we can go off of vibes. We don't need to have passed our electricity and magnetism course really to do this properly. Preferentially, could use one right about here. Ooh, that's good. That just worked out. And then, yeah, kind of want one here. Give us that lovely grounding. Over here, where it gets split. Oh, it makes a face. Oh, okay. And then get one here. And a buddy over there. This is a lot easier because there's not a lot going on this side of the board. If you guys have any questions, I know this isn't like a class lesson, but we are just hanging out and doing this. It's not anything too structured. I have all of my viewer here. I'm gonna come in here and hug these signal traces a little more and put one on the outside over here. Nice and clean. Now we can get ones in here too. Probably just one. Give us a little grounding on these amplifiers. That I can't really get into. And then that is okay. I think that's fine, actually. So yeah, that's top and bottom from that big ground. So let's just get one near the plug. And one on the other side of the plug. And then a couple down here. Again, I'm going off of absolutely no science on this. I'm just sort of peppering them down to staple the ground planes together and provide some kind of like a coverage of blocking RF and stuff. Like these are antennae going through there, but I can't fit a via anywhere around here, so we're stuck. Okay, so that's I think the best that I can do for the ground plane on this thing. I really don't feel that I need a ton of vias on there. I would like to get this total outer, this like one single wire. It would be nice if I could tie that to a couple more grounds, but I don't really think I can wedge one of them in there. I could put a specialty via of a different size on there, but I'm trying to keep it simple, you know? KSS, try to use as few special things as possible so that your design is just easier to work with. Yeah, this would be a good spot for a via right there, right there. But I absolutely can't fit one of these in. That's not even the right one. Or can I? Oh, I can. Okay, let's put a couple of those on there. Definitely can't fit it there in that little stretch. And if I was being a real stickler, I'd put one at the beginning of that, but I think it's fine to just put one like out here. All right, that does good. That's good. Let's get this one tucked up here a little. Oh, there's a trace right there. This is as close as I can get it, huh? And then I'll put one down here. All right, I think I've done the best that I can. Probably should put one right here. Yeah, let's do that. Right here in the middle. Let's see, any other like, well, this whole thing is a weird structure that I can't really do anything about. Yeah, I can't. Well, it took it. It took it. Okay. Well, all right. Okay. I don't think it'll take it down there though. Yeah, we'll just leave that in the middle there, sort of midway through this giant, because here it expands out. So this is where it gets tied into the other grounds better. It's going around that. Maybe do one here, but it's got this one. What just happened? Why did it scroll suddenly? Let's just see if, okay, I'd see if I can fit one. Absolutely not. Nope. It's not going to work at all. It will not allow me to do such things. Why would you do this? This is perverse attempt to somehow tie your ground planes together. You disgust me. Okay. And then what are we looking at here? So that's a big ground plane here. That's kind of cut off. It's over there and then over here. Two separate spots, but we can't get one in there because I put those traces too close to each other because I wasn't thinking when I did this. Let's go back up a little bit. I'm going to copy that one. Get them right there. Do another one midway up. We got one there. We don't have one here for this section, which is weird, but I can't because they're too close together. What I can do is do another one of these here. What? Oh, it worked. Okay, cool. I expected it to throw like alarm bells when I did that. Okay, and then we got one here and there, so that should be fine for this area. Cool, cool. There's no way that I would see any difference between putting 1,000 of these vias down and putting like 10. I don't really think I would see a difference in the signal integrity. Okay, I think we're good. So that's doing the vias. It's a lot of just like, I don't know, right? Because they're free at the numbers that we're using them in. They're not expensive for me to implement on this design. And you know, they'll be placed by machines, so it's not like I'm burdening somebody with a bunch of weird work. This is sort of an orphaned area, but I can't get anything in there because the ThonkyCon specifies that I need to avoid solder on the top layer in that circle. And these are parts that I modified from Emily Gillette's library from the publicly available files on the design of the mutable instruments circuits. And it pushes this ground pin in a little bit, and it uses the original Funky Kong oval, which is a little wider than I think it should be. It could be a little bit more narrow, and I'd probably have a lot more room for circuit elements if I do that. If I'm hard pressed to get all of my traces in, one day I will narrow them down to specification. For now, this is good, and I have seemed to have been able to do the layout without too much belly aching. So, ground planes are all tied together. Due to the limitations of the software, not limitations, due to the design elements that are in the software that keep you from making mistakes, I'm pretty sure there are no mistakes on this board. But at this point, what I could do is run a design rule check. The DRC is kind of important for designs like this. My DRC is set up so that we are within the design parameters of Seed Studio. So Seed Studio dictates some of these design standards and the capabilities of their own PCB manufacturer. I'm gonna do a quick DRC check, although technically these would be violators. So maybe we don't do DRC now, maybe we do our board labeling now. Although the DRC can uncover issues that would require you to change layout. Oh, we're in an ad break. We're in an ad break, so I'm just gonna take a minute here, stretch, get a glass of water. I got somewhat of a seltzer water sitting here. Gotta move those legs or I'm gonna get blood clots and my face will blow up. Oh look, my Firefox tab has crashed. I don't know if anybody using Firefox having a lot of crashes lately. I had it completely get rid of all of my cache for sites that I was logged into and stuff. So I had to log back into everything. I had to reset up YouTube. I had to get the Tamper Monkey script again for YouTube. Absolutely ridiculous. Huge amount of work to get back to where I was with all the plugins and ad blockers and stuff like that. I don't know what in the world happened. And then it discarded all of my Reddit enhancement suite stuff. So I was missing all of my filtered subreddits. And so every other subreddit that I had in my feed was something India. And I'm like, I don't need all of these. I don't need to know your local politics. It's okay that you guys have those spaces, but it's like, I think they've been botting a little bit. That or just enough people have cell phones and discovered Reddit, and that happens too. Haven't had any issues with Firefox crashing. How many tabs do you have open? It's like 5 or 6. 1, 2, 3, 4, 5, 6, 7, 8. 8 tabs in 2 windows. What is your favorite Linux? There are as many Linuxes as there are organisms in the ocean. That's a tough one. I've been using Bazite on a handheld. I find that to be okay, which is basically just SteamOS. Bazite has the desktop on it though. I have not used any particular flavor. I've been using a lot of Raspbian. And then, is that Linux? Is the, it's not, what's it called again? It's not FreeBSD anymore. It's, well, whatever I run on the server, I don't remember anymore. That thing has doggers. Odd that it's happened at all. I've had troubles with my computer, like resetting, and then something like when the computer resets randomly, something causes the AMD drivers to disassociate with the card, and so it installs generic video drivers over top of them. So if I try to open the AMD software to edit settings, it'll not open and crash because it doesn't have its association with the hardware, and I have to reinstall those drivers. That happens sometimes when I get up from my chair and there's a huge static buildup, and it'll cause the computer to go, and then do that. That hasn't happened lately. That's been very, very seldom. But I've got these weird, like my computer has ghosts in it or something. I don't know what the hell the deal is. Because Firefox video, I saw green lines before this thing happened. There were green lines that were flashing. I opened up a Minute Physics video and there were green, like little green lines on that. Maybe I need to disable hardware acceleration. Maybe that's what's doing it. But my graphics card in gaming has been amazing. It's really nice. The Radeons are really, they've got good color and all that stuff. But I found that hardware acceleration settings in Firefox and Chrome often cause crashes and video artifacts. I see. Wait, now we're in an ad break? What the hell was that? Oh, that was ad break starts in. All right. Hey, sorry guys that you got an ad. There's a Tamper Monkey script you can run that turns it so that I go low quality and you still can hear what's going on. I think Twitch ads are incredibly intrusive and I hate them to death. But a necessary component of Twitch ads running in the middle of my stream is that I get discoverability, and so people can find my stream. And I'm talking to the people who aren't watching ads, so or the people with scripts. Good on you for having a script. I really think that Twitch should use just a pop-up in chat. Remember when Twitch didn't suck? Yeah, remember when subbing to a creator meant you were directly supporting that creator for the very purpose of not having them fall to the advertisers? That used to be like the ethos of Twitch, and now it's like, how can we monetize ourselves more? That's not, I loved it when it was like public access television, man. But like public access television, we got to run ads. But it was like a new thing. It was like, it wasn't pirate radio and it wasn't public access television, but it met somewhere in between and you could just watch it and then people would generously support their favorite. What's up, 7-3? Well, here we go. This is a first-time chatter. You're probably watching it. Are you watching an ad right now? How would there not be an ad? Maybe you've got a script. Hopefully you have a script. Because, hello, hi, welcome to my stream. You are you, oh, did it end? Because officially it ends in another minute. And that's when I can get back to the circuit board. But for right now, I'm just complaining about this situation where I have to stop everything I'm doing when ads are running because I don't want to steal content from people who aren't paying. What was that? Wait, what? You got to rearrange the sentence sometimes. Yeah. Yeah, I liked it when it was for love of the game and, you know, generous people would support the creators. I don't mind watching ads. That's a fine thing to do, but I hate them. I hate them. I hate them so much, just with the bottom of my heart. UC Bother's generally a really nice guy, and he's very friendly and patient with Twitch, and his friends say he's so patient, and then I say that from the deep, deep cockles of my heart, I fucking hate ads. They make me grind my teeth. 4 seconds until the ads are done. I think they are a deep problem with society. Let me put on my Joker makeup really quick and I can get into this. Hi, everybody's back from ads now. Sorry about that. I forgot about ads and then I heard the click. Laughing. Listen, the other day we set up a synthesizer stream so that while there were ads, it turned off my synthesizer and I had to redo all of the connections and stuff to it, right? If it supports the streamer, then I don't mind. It doesn't. It's a pithy sum. I don't think there's a single streamer out there that makes their revenue off of ads. They might make a little bit on the top, right? You get your big streamers, they run an ad, that's thousands of views. I have 44 people. That's actually a big number. 44 people watching is a big deal. It's very nice of you guys. But the ad revenue that I get, I haven't really tallied it up yet. I have yet to. Didn't I? On the 14th, like, when did we start doing this? We started doing this like this month. So I don't know yet what kind of revenue I'm going to see, but it's probably going to be $1. It might be $2. It's not going to be a lot. So these ads, what they do is they support Joe Twitch so that he can go and kiss Jeff Bezos's bald head. That's what they do. They allow that to happen. And I don't support that kind of perverse baldness. It's not true. I do support that. It's super weird. I love it. No, but I don't support Jeff Bezos doing weird stuff on yachts. So the ads really just aren't doing much. They're not going to do much for me. There's like a whole sponsored stream system that I could use to play like Minecraft, but the payouts are pithy because of the amount of numbers that I have. It's like, hey, play Minecraft for $5.30. And I'm like, no. What's sad is that YouTube and Kick are even more evil. YouTube has a better player and it doesn't delete my videos after a month or 2 months or whatever. Twitch does delete the VODs. So there's about 8 years of bother content that just aren't archived. They're archived on my drives, and that's that whole push to upload that I did with all the making the thumbnails and the uploading. The uploads took a while because they're 5-hour streams, and YouTube's algorithm was like, screw you, buddy. Like, so I got some new viewers that way, but like it should have popped off a little better. I was uploading a 5-hour stream a day, but nobody wanted to watch 5 hours of bother. This type of content is probably better for cut content. And so in that vein, I'm always under the debate about whether or not I want to stop archiving. I've lost some of the archives. There's some connecting tissue between these newer streams and the stuff that I uploaded to YouTube that is just gone because my hard drive, I thought the 4 terabyte hard drive that's in that computer was a 4 gigabyte memory stick. And I formatted it to be a Raspberry Pi. Now the drive is named Do Not Format Me. Well, grinds my gears, that hard drive is expensive. Yeah, well, what I do is every couple of years I'll buy a 4 terabyte hard drive. And what I'm doing here is I'm recording this stream onto the SSD. And then when the SSD fills up, I'll put it over to a platter drive. And it's on the SSD because it's being recorded in such a way that if the computer dies, because our power out here in the deep suburbs is terrible. I mean, I'm in Philadelphia. I'm in Philadelphia. Anyway, the power here is a little wibbly, and sometimes it'll go out. And so if the power goes out, I get a decent amount leading up to when the power goes out recorded. So no, I can't RAID the drive. There's only one drive that fits on the computer. The computer's a weird redux of a rack mount computer with this thing falling down. This is necessary. The rack block is necessary because the graphics card is sitting vertically and the tubes on the graphics card stick up above the case. Of course, I do have a 3M PCIe wire, like cable, that I could use on that, and then I could turn the graphics card, but that's work, and that would take out the streaming computer. I should have known as soon as I was done with this like segment of rebuild on the computer, this would become the permanent stream computer forever and ever, and now AI has doubly made that so. A viewer actually sent in a bunch of sticks of RAM right before, like literally while they were in transit, RAM prices skyrocketed, and so I'm sitting on like a nest egg of pure gold in these RAM sticks that a viewer sent in. I put what I could in here and tested them, and they're all good. So we've got a little bit of scalability on the computer, but this is still a pretty old computer. We don't need a lot of computing power to do this. We basically just need to run Fusion 360, which I'm very much annoyed with Autodesk for not having a Linux version of this software. There is, however, a browser version of the software, so maybe I can try that out. But you need to pay for the browser version, and I don't want to. I avoid using the paid features on Fusion 360, even though Autodesk gives me a copy with what I assume to be a good number of features on this copy. They are providing me with a free version of this software, but it's like probably worth a pretty big monetary value. And if I use those features on stream, it's like encouraging you guys to get the paid version of the software. I want to continue to use the free version because you can use this, and if you're under a certain amount of revenue, you can also, use this for free. I want to be on the same level as you guys. I would almost consider deactivating features, but since I am streaming, I do a lot of projects. I have a lot of files in here. So that's what scared me about my version dropping down to the free version back when I had an educational copy. So anyway, this when you're doing stuff on the Linux command line, a single letter typo can mean that instead of formatting your old 4 gigabyte SD card, you're formatting your 50 terabyte RAID array. Oh God, that would, the feelings that I felt when I accidentally formatted my video drive are feelings that I would not like to felt. So I would not wish that on my worst enemy. I don't like the idea of sneaking these in on the other side of the pins here because that's where the soldering iron is going to be. All right, so let's do markings now that we're done with the ads. By the way, during the ad break, for those of you that actually watch the ads, weirdos, You freaks. Those that don't mind the ads and decided not to run a script or hop on over to YouTube to watch it without the ads, I basically just complained about ads the whole time, so you really didn't miss anything. On the final design, this stuff is going to be covered by connectors, and now this is normally what I would do is come in here with just this two-layer view where I'm viewing through the thing. I would then figure out where all the markings are going to go. But instead, I can actually use the 3D representation of the board to tell me where all the nice places to put markings are. Now, there's still one thing that I haven't considered, and that is these silk screen layers. So we need to reactivate the top silk screen and the bottom silk screen. So that would be... They've put these in categories. It's kind of nice. So silk screen's top... Oh, don't lock it. Where's my... This highlighting is not good, Autodesk. I need your help, Autodesk. You need to work on night mode a little bit better. I can't see what's under the cursor. It's just all blue. It's there. I just can't see it. So the bottom silk screen and the top silk screen I want viewed. I guess that's what we have. Names and values. I guess they're taking it. There's silk screen, names, and values. So names would be U1, R1, etc. So I guess we're going to take our names and view those. And I want to move all of these names markings off of the board. I do not want them to be represented on this board because we don't have room to put them down there. I just don't have space for them. I will just have to know through my design what's what. Oh, I'm trying to move this and it's not moving. You got to right click. No? I guess, oh, I have to unlock it individually. So unlock. That one, because it's locked and unlocked, you can lock parts down and that'll help you a lot. Because if you accidentally click on something and you move it, it'll blow up your software. So clicking lock makes that little crosshair go sideways, which symbolizes that it's locked in position. Because the Funky Con connectors, these big parts here, I don't want those ever to move. We already used the arrangement tools to put them in a particular place. New to PCB, is this going to be liquid soldering? No. You know, if I'm feeling frisky, but I don't think I can, I could get like a stencil made and then you wipe solder paste and it covers all these little pads. You can also just use like, you know, a syringe with a special tip on it. Like a dish. You could use a syringe with a special tip on it and you can deposit little dots of solder paste and then you place the components on it and you put it into a toaster oven. And the toaster oven just heats up and everything solders. But this is going to be a very two-sided design and I'm going to have to like cut some pins in order to make them not blow everything up. So this will be hand assembled. Oh my God. Something about tuna salad and the worst heartburn I've ever felt in my life. I took 2 famotidines this morning. All right, so what I'm doing is I'm getting these obscene markings out of the way. And if I click on their individual crosshair, they'll move. It used to be like in Eagle, which is Eagle is the software that Fusion 360 kind of hoovered up and made their own. They bought Eagle, which was annoying because Eagle used to be a piece of software that you did not have to subscribe to. Now, there is value added in AutoCAD having control over Fusion because AutoCAD is a very good-looking program, and so I can make very good-looking 3D representations of PCBs now. Whoa, whoa, whoa. I gotta make sure that I'm only selecting the markings. So in a normal PCB design, if I had room to put all these markings, if the silk screen could get small enough, I would make these the appropriate orientation and location and size and stuff using the change tool so that you could change the same thing over and over again. That's what the change tool helps you do. It's a little wrench icon. But in our case, all we need to do is just get this stuff out of the way because there's no room for it. Okay, here's something about unlocking. When you go to unlock, it loads an unlocking tool and then unlocks it. But I'm still in the unlocking tool. So I need to click, hit escape, and now I'm not in the unlocking tool, and it'll allow me to move the marking. It's one of those unintuitive things that the CAD software does. I think if I hold Control, yeah, no, Shift, no, Alt, nope. Nope, looks like I just got to go for the crosshair. I could technically unview the layers, and that might allow me to get to... Oh, here we go. If I just highlight a section of it that's not conflicting with anything. All right, let me actually make sure that these sort of... Yeah, so we're not doing that. That one goes way down here, okay. Which one are you? You're the one in the middle, okay. Because that'll just help me to identify these parts when I build the board. $17, $18, $19, C5. J7. Where's my U marking? U something or other. Let's get rid of the copper layers here. That's a little easier. Unlock. Doink. No, I just locked it again by clicking it. Ah, unlock. Wait. Why is it not going? Click off. Click escape. Escape again just in case. Okay, there. So that's J6. This one is C9. C10. These are decoupling capacitors. They are going to be impossible to work with once the connectors go in, and I'll show you guys why in just a little bit here. Now I need to establish, I should have taken notes on the other circuit board, what the maximum size is for silk screens on Seed Studio. We can check their website, of course, to get that answer, but when you get towards the smaller silk screen markings, they start to look blurry. And I have an example of that somewhere. I don't think this one... Hold on, let's just check. Yeah, I didn't get too small with these because I knew I'd be looking at this module and wondering, you know, what pin is connected where. It's just based on... I'm crediting who I designed the board based on. Yeah, there we go. Cursed text goes here. That looks like it's out of focus. But it's not. Yeah, it just looks blurry. That's what, you know, Seed Studio's machines just look blurry at that text size. Oh boy, don't move the resistor. No, 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 no. You stay there, and only your text. There we go. So just getting the silk screen markings out of there. Oop. You unlock and click escape. I hate that I have to do that. That's just a leftover from how the tool works, how the CAD software works. Oh, that's locked. Unlock. Unlock. Let's see, D6, D5, and then J4, unlock. There we go. And escape, escape, escape. Now I can move it. So dumb. so dumb. J4 and stuff, that marking doesn't really matter, but any advice on how to start hand routing PCBs in Fusion instead of using the auto router? Yeah, so I mean, it's fairly easy to do. Basically, a lot of the work is done in arranging your components to where you want them to finally be. In my case, I used some auto arranging tools to make sure that these were spaced out properly, and then I locked them in position so that while I'm clicking around, I don't accidentally move something and blow up my entire circuit. From there, once I got sort of the mechanical pieces that I wanted anchored down, I organized my circuits into functional blocks. So, for instance, going to one piece of the circuit that logically makes sense for it to all be together, I would highlight that, unhighlight the gate that it was to, because the gates can be swapped around. So unhighlight that and then go into the 2D design, and then that'll let you separate out the parts from that specific circuit structure. So in my case, I've got a lot of repetition on this board. We've got 3 amplifier circuits and 1 amplifier LED circuit. And so I arrange them within a functional block and then cut and paste that to a second functional block down here. Once I get them arranged, I try to keep the air wires as short as possible. And there's actually a mistake that I made. 2 of these are swapped, where it would be cleaner if I did it the other way around. But I'm not pulling hairs, I'm trying to get the design done. So I put them into functional blocks of components and then worked them around these connectors, these pervasive connectors that are gonna make this design difficult to put together. They're the main feature of the whole thing because it's Eurorack, it's modular synthesizer. And once I got that together, then the limitations became, how many traces can I get through this? How many traces can I get through this? If I wire these up and then wire them to their ins and outs, how can I get the individual traces for all those leads to one another? I need my LEDs to be exactly here. Those probably should be locked. You know, stuff like that then dictates where your traces run. And then as you run new traces, you rearrange the ones that are already there or rip them up and reroute them. So there's a whole slew of crying, trying to get all of your stuff down. With the limitations of the 2 HP Eurorack, a lot of those choices were pretty much just made for me. I didn't have to think about signal integrity because I need my traces to fit in the first place. So in a larger design, doing more stuff, again, I don't like using the auto router. You know, I like running these traces myself because I can think about things like, well, is it going to run into any like weird capacitance or interference by being next to this thing? But I can tell you, in this design, I could not make any of those considerations. I basically just chose a reasonably small trace width, which I think was like what was it again? Hold on, wait a minute. Power is, of course, larger traces, but yeah, 0.2 millimeter for my general signals, and then these get up to the 0.4. So 0.2, 0.4, I have some 0.6s, those are the ones that go to the headers. But again, like space limitations were the big one. So Seed Studio can reliably go down to 0.2. They can probably get smaller than that, but I don't know. I don't need them to. I don't need to pay for that. So all right, so we're just getting silkscreen markings out of the way so that things can look good. That looks so weird to me. My brain will not. If I hit F, we flip the board. There we go. Yeah, no problem. I mean, a lot of it for me is vibes right now, just because if I tried to stick to the principles, I wouldn't be able to. Oh, come on. I hate that. I hate that. Unlock, hit escape. It's like, you can't do that. You already did a thing. Where is that? Oh, there it is. It's all the way up here. D1, C11. I'm going to flip it again. I'm not used to looking at it like that. When we do the 3D board, it's going to look real disorienting. That's this one over here. Okay. Disorientating. C3. Why is that one upside down? Weird. There's no telling what happened to these markings as we went through. And we're pretty much almost done this board. I mean, I don't think I'm going to run into a lot of design rule issues, just because of the way the tools handled it. Pretty much visually tells you if you're making one of those big mistakes, like, you know, something is on top of something else. Those are easy to make mistakes from CAD tools because you're viewing through the board and you're just not used to it. back in my day, we didn't have these fancy visual indicators, and you could run the trace anywhere you want. And I had a circuit board that I was making for a research thing for a brain monitoring probe, and I accidentally ran a trace just across everything. All like on the top layer, it just ran horizontally across a whole bunch of amplifier lines. It's like, oh man. I didn't see it in CAD because I was looking through the board. Why is that unlocked? Unlock. Oh no, I was in the locking tool and I clicked. Come on, man. It really, if you right click and choose unlock, it should only unlock the one thing and then exit the tool. That may be one of those things that they missed when they were sort of retooling Eagle into Fusion. The dogs are barking at the Four Seasons Total Landscaping. Our landscaping comes from the same place as the political weirdness that was that press conference. Forgot to add the file for the traces. Oh no! So it was just like a it was like a modular synthesizer front panel where they don't actually have any traces, but they still use PCB authoring stuff. This is just like, it's got plated through holes, which is weird, but there's no traces on it because it doesn't have any electrical connections. Oh man, imagine. I like what are these guys? These are like three tom. What 3tom did on this module, and they've got like decorative elements that are on the solder mask that are solder masked. Pretty cool. Although technically it looks like these are not grounded, which is not ideal. They look cool. Yeah, those are isolated. That's not good. They should be connected to ground. All right, we're getting there. We're getting there. A little bit of a slog. Unlock that, and then watch. Doink. That should have unlocked. Why didn't that unlock? Wait, what the? Oh, that's so evil. So if I right-click this one and I go to unlock, and then I click this, it'll lock. But if I right-click this one, oh, hold on, let's lock this again. Wait for that to go crooked. Did I not just say? Lock. Okay, so now that's locked. Oh wait, no, yeah, okay. But if I click this one and I go unlock, and then I want to unlock this one, and I click it, it doesn't unlock. What the? But if I go unlock and then I click this one, it locks it. Why does that only go in one direction? I think that's an error in the software. I think they didn't root out that functionality and change it. That's so stupid. Unlock that one. And then I click this one and it locks. But if I okay, hurry up, come on. Why is this so clunky? Trying to lock. There, lock this one. So, okay. So now if I unlock this one, that's perfectly reasonable. What's up, Groovy? It's perfectly reasonable that I would assume that I'm still in the unlocking tool. Oh, it didn't do it until I hit escape. This is ridiculous. Okay, anyway. What in the world? All right, you come over here. Okay, we've removed all of those markings. So now we've got just a representation of what's on the top and the bottom of the board. So on the bottom of the board, I would like to put Twitch TV Oh Bother and the date. The problem being that I don't think I have any space for it. Okay, we can maybe put it here. And the vias are going to interrupt the text. So I should try to put it somewhere that's not occupied by vias, which is impossible. Which is impossible. That'll get the W and the slash. It's not going to do. Like I said, this is the fun part. We get to kind of rearrange text and do fun stuff like that. Now, actually, the top silk screen should not be visible for this. So where's top silk screen? Mechanical silk screen. I like that they put these into categories, though. This is very helpful. Twitch TV/obother. This needs to be the current date. The circuit that this was based on was done in 2025, but now it is no longer 2025. The date for today, 7/30, 2026. Okay. I had that on an angle because of the space limitations of the previous design. I have no desire to change the angle. I think I like it. How it go? I am super heartburny right now. And something set off my cat allergies again. Is this going to be an everyday kind of thing? I don't know. Where are you going to go, date code? I have strip here for the stripe. That's important marking that tells you what orientation to plug your flat cable into, and then your friends will inevitably get it wrong and blow up all of your work, but at least you tried. Too close to the edge, I think. Where else? These are unfortunately pretty symmetrical, and I don't know if I can get the date code in through there. Maybe we can throw it right there. Same problem as before. Of course, I've created problems by having it on a funky angle, but I like the funky angle. I don't know if we'll do any artwork on this one. I kind of want to get this one just out of here. I want it to be done. So I may just do the bother URL and the date code and be done with it. I guess I'll work it in like this. That should reasonably avoid. Yeah, that seems pretty good. Now, the thing is, we've been viewing this through the top, right? We've gotten used to it from this side. We need to do a rendering of this board and see what it's actually going to look like in 3 dimensions. Icing on the cake, what am I doing here? Let's see. Somewhere on this board, I'm going to put... No, we're not routing. No. Let's get out of... No, I don't want to see the top layer of copper. This stream brought to you by Tums. If they want to sponsor me, they are welcome to contact me. My contact is in the stuff below. They're crazy. Yeah, I got a sponsorship from Chalk. Just Chalk. On the bottom silk screen, that's where all the markings are really going to go. So we have selected the bottom silk screen for our current layer. I need to go to the document tab, not the trace routing tab. So we can document using all of these different drawing tools. I'm going to be using some arcs. And we just simply need to draw... Oh, no, that's not it. A couple arcs. Where are arcs going? Well, we need it to go like that. And then I'm going to need another arc, but I need to change where this thing is. I have a vision. I have a vision. Don't you worry. Or do I really feel like drawing a pair of balls on my beautiful PCB? I think, yeah, I do feel like drawing that. Yeah. We need a particular type of line, and I guess it's going to be the bendy line. But not that way. It needs to bend the other way. I'm right-clicking, but it's not changing. Bend the other way, you stupid line. Damn it. What's that you said about sponsorship? Said something about being sponsored? Who would sponsor you? Why would they do that? Oh yeah, different sizes. It's a cold day. It is a cold day. Hey, what's up, Gonad? We're doing very important work today. I'm doing very important stuff here. The important part about doing this is that you break the shape up. I need stuff that gets in the way of it, so it'll actually get cut. So I have plausible deniability. Like that. Oh, but that might mess with... Seed Studio might not appreciate that. That looks a little bit more like just a generic blob. I think I like that a bit more. Problem is I can't... Yeah, maybe control. There we go. All right, now we need plausible deniability. In the form of stuff covering it over. There we go. That'll give it a nice interrupted shape. Clone it and cover the board with hundreds. They won't notice. Oh, this isn't about... No, this is more for like Twitch. This is plausible deniability in the face of Twitch. I did this with the other board. No, I think Seed Studio would still print it. I wonder how pornographic I could get before Seed Studio would not allow that. See, this is a chef's hat that I put on another board. It's a chef's hat. Oh, right click, edit. Oh, no, that's not. Not quite. Not my tempo. Not my tempo. There you go. It's a chef's hat. That's going to get cut off. It's a chef's ha. A chef's ha. Ah, okay, that's good. Pretty good. Actually, there is pretty good. That'll sort of... It's a chef, and then that'll kind of get a little cut off hat. Perfect. Okay. That's the memeing part. I could have probably taken a meme in and used some of the user language programs. Let's just, yeah, here. And I could probably have taken a meme in and used like the user language programs to copy it from a bitmap into a thing. I've done that a lot. Actually, you know, you guys see an example of that every single time I use the face camera. I took an outline image of dick butt and I threw it onto that board. That's using a user language program that will use polygonal fills to fill in where all that stuff is. And, you know, the CAD software is fine with it. It's still in vectors, but it's a little sloppy. I've done it where I've taken the oh bother thinking emote that we have vector art for, and I've put that on a board too. Usually when it vectorizes something like this, it does it very inefficiently. I do have a more efficient vector of that, but again, like it'll only represent it in outlines and it does all this stuff to it so that it makes your design pretty toxic to click on afterwards because you can't quite click around all this stuff. I could put Weird Cat on there if I could find a black and white Weird Cat, but All right, let's put the name of this. So this would be powered mult. I guess I can put it crossways somewhere down here. There's too much stuff. Let's just put our own text in there then. Does it automatically do the size? Let's just check. No, it does not. It's huge. What is this text size? 0.8. 0.8 of a millimeter. All of these are English sizes represented in metric, so they're all a mess. What layer are you going on to? Should be silkscreen bottom. I guess as soon as I click it in, it'll go. Oh no, I've just gotten so used to reading backwards. Oh my God. I got so used to reading backwards that, oh man. Powered mult. Where the hell am I going to put that? It's a chef's hat, takes up the space that I would have used. Let's see. The date code is also getting in the way. The Twitch TV, oh bother, but those are all necessary. Power. Blah, blah, blah. Just trying to keep the vias from cutting it off. Actually, those components are not on the top. This is a huge area right here. I forgot about that. This component is not there. That's on the top layer of the board. Make it look like a cool logo. I don't know. That's going to be a mess anyway, so. Powered mult, Twitch TV bothers in there, although that could probably have gone here, but powered mult is right by the power connector, and then Twitch TV bothers right nearby, so that should be pretty good. Can I move the? Well, it's not touching anything where it is. Everything is revolving around these capacitors, huh? Yeah, that should be fine. Nothing should interfere with that. And then the date is over there, even though that could probably also go like right here. I don't know. I want to put stuff in kind of avant-garde places, right? So I think that does it for all the markings. We got the stupidity of drawing a penis on our circuit board. We have definitely cleared it up about what the purpose of that symbol is. Unequivocally, there's no getting it wrong. We put identification of the stream. We put the date code on it, which isn't a code, it's just literally the date. We have a very vital thing here, which is the stripe marking, so that we know which end the stripe is. I have a plus sign right here that I'm just putting next to these guys just so you know what that is when you look at the board. And then all of the J's and R's and C's don't fit. They don't fit, so we don't put them in. They'll just simply be for the designer with their CAD files to identify who's who. And that's it. I think that's all we really need. You know, given more... Actually, let's make this larger. We can get away with making this larger. Maybe 1 millimeter. Make this one 1.2. My dot key sometimes works. Oh, I have yet to find a keyboard that I really like that I could put on this computer to use with Stream. It looks like brewed now. It looks like brewed malt. Brewed malt beer. Yeah, Momo is gone, by the way. Momo is gone. Momo has been returned to Big John. I know, I could use a malt beer. Malt beer. We'll put plus by the plus on the header. I've given you everything. A plus sign a stripe marking, plain as day. Please, for the love of God, do not plug this thing in backwards. I at least gave it diodes to help with that. Give that a little breathing room just so the connector doesn't cover it over. All right, let's take a look at what this looks like in 3 dimensions. One of the things about Fusion 360 and cultivating your own nice 3D models for all these parts means that you can bring this into 3-dimensional space and it looks really good, because Fusion 360 looks really good. I'm not just biased by the fact that I only really know how to do this in AutoCAD. I know how to use other CAD software. The workflow is just a little clunky at first because it's different from Autodesk's workflow. But I cut my teeth in Engineering 101 CAD stuff on Autodesk. We had to use the command line. This is 20 years ago plus, more than 20 years ago. Johnny Mnemonic has the Autodesk logo in the beginning, and they're credited at the end for 3D work. It's kind of crazy. In the year 2022, I think it was. Anyway, I use AutoCAD. I use the Autodesk tools. Maybe that imparts a bias, but I do think it looks better than KiCad's renderings, and so I lean into that pretty hard. And so what we'll do now is we will render this in 3D, and we'll be able to see what it looks like with parts. Good parts. So that's just a button. I just hit this button right here. Boom. Boom. You can change the settings on that render too if you want to take a look at what it looks like in a different color PCB, but the representation of the colors is a little weird. So I just leave it in green. Update the board. Just give it a minute to do its thing. It runs kind of its algorithm in order to create, place all your 3D components down, and it even renders the traces in 3D. It's crazy. Other softwares will just put an image of the board down, and you can actually get this one to do that too. I had some trouble with it rendering circular traces on the board that sits next to my face cam. The 3D stuff is always kind of a reward. Yeah, that's exactly how I'm thinking of it too. You're absolutely correct. So you're kind of like, yay, I get to see it in 3D. Awesome. Okay, so here we are. Yoink. Look at that. Beautiful. Beautiful. This could probably move over. I would rather have it in this open area. Stripe is looking a little far away, but I'll keep it there. I could make it say STRIPE, but I like it because it sounds like it's saying strip. Strip! It's like kind of like, whoa, circuit board, what do you want me to do? Yeah, looking good. Looking good. These are the contention point. I have to install the socket before I install this piece. And if I install the socket, then I need to install the decoupling capacitors that I snuck in between the sockets. It's a lot. It's a lot to deal with. Yeah, 3D, it's really cool. And these are the thonk connectors, I believe, from the model that we showed on GrabCAD earlier. So they're nice and detailed, but I didn't use the stereo thonk in this. I'll have to come up with a board design that uses the stereo thonk because I bought those things. I still have them. But yeah, I'll have to... I think what I did was I recolored the outside for the stereo thonk. The stereo thonk does not have the disconnect pin, so it's just right, left, and ground, or tip ring ground. Are we going to get away with that? Are we going to get... Is that... Yeah, I think we are. It's a chef's hat. It's a chef's hat. It's just it's a chef's hat. It's the Vias. The Vias make it a little bit, it makes it look a little weird. It's actually a chef's hat. Oh, we have an ad starting in a minute. We got an ad in just a minute. I know it doesn't, but that's not what it is. It's a chef's hat. This is the hat that a chef would wear. It's one of those with the folds in it that symbolize, the different ways to prepare eggs. I think, is that what they are? Let's move over powered mult. Powered mult should be presiding over those pins. Very minor thing to change. Very minor thing. We'll see if we can get it to not interfere with any of the vias. Not that it would interfere with them, it's that the via would keep ink from printing. I mean, wait a minute. What does it look like in relation to the tantalum caps? Because if that was like over the tantalums, it needs to be a little bit further up from that. Okay. This is, so you, in the past, and I'm gonna, Old Man Bother here is starting to pontificate. Old Man Bother, in the past, you would not be able to see your board like that, and you wouldn't be able to flip this. Not in this software, in other software that I would use back in the day, you wouldn't be able to get that cool view of the 3D board. I wouldn't even be able to get a finalized flipped view. It would be always viewing through. So when your board comes in the mail, you would get something that looks totally different from what you're used to, because you've spent all the time poring over this design and making sure that it's all good. I don't like this, but I think it's okay to do with a trace this big. I probably should have curved that a little bit more, but I'm not going to change it now because we've got all our ground planes and stuff established. Yeah, the process for this is going to be kind of crazy. It'll be install the between connector parts, install the power socket, then what? Oh, install the connector and flatten it, the two connectors and flatten them, and then install the rest of the parts. That's crazy. Oh, we're in an ad break, so let's hold on for just a second. All right, well, I think this will be ready to order. So we'll go through the steps of checking it and then getting it ready for the order once we come back from ads. So we're just gonna wait here for ads to expire, and I'm gonna continue to talk to you guys. What's it doing outside? Is it, I don't think there's storms today. No, it looks okay. I can't quite, I like can't bend myself all the way back there to look. It just looks miserable outside. I went outside to take the dog for a walk in the morning, and I came back and I was like, cat allergy for some reason. Oh, Big John also left behind a flux pen. This is like totally different from the stuff that I use. No clean flux paste. This is lead free, no resistance, halogen free. I may still order the stuff that I use, because this is tacky flux. It might be a little, I mean, they might be a little different. There might be some slight differences between these. But if I can use this, I'll use it. I don't know how it smells or breathes. I need my horrible, horrible, dangerous chemicals. It was very cool of John to have me, Big John, to have me do the Momo work. We got that in and out of the shop pretty quickly, and it seems like Momo's working once again. Big John's going to put it together, and maybe we'll be able to see it in action in the future. But that was a fun little project because it didn't involve, we didn't have to go like head to toe with the design or anything like that. It was literally just I don't have the means to solder this. I need your help. So that was really cool. And then programming those motor controllers was crazy. I guess BLDC motor controllers have gotten nuts. I am just familiar with my slightly hobby involvement in some of these lower power ones, but it seems like the high power ones have come quite a ways. They're damn near servos at this point. It's crazy. I have the Granite Devices controller to control my big BLDCs for whenever we CNC this or find a job for those motors. I don't think the pick and place will be using those motors. That's a little much. The pick and place will be unpowered. All right, everybody's back from ads. Welcome back. Just talking about Momo and BLDC motors. Momo's gone. Momo's back home, where Momo will get the rest of the wires placed in, and then hopefully we can get an update. But, oops, oh, stop looking at my butt. Boink. All right, powered mult. So we've got our markings down. They're a little bit sparse, but I think this is good. I always like to be able to put what the thing is on the thing, and we put a little design behind it, made it look kind of cool. We got today's date, we've got my URL, and then we have, something jokey on there as well. We don't really need other markings. We're not really going to need other markings on this. It's going to be a challenging build. I have to do it in a particular order. There's only one answer for that question. But other than that, I think we are ready to go. I could roundinate the edges a little bit more. They're not very evidently rounded, because this is the original design here that we sort of aped off of. And oh yeah, the version of the board. Yeah, I should put a version 1 on here. Let's do that real quick. Forgot the version. We'll just put it like, I don't want it to be like powered mult version 1. I don't want that. So I'm going to put V1 like up here. Well, this is where all the information is. What do I want version number? We'll just sneak it in there. For once, I'm not going to joke. I'm just going to do V1. 0.0. The point. Dot. There you go. Version 1.0. Yeah, maybe smaller. Point. I think 0.6 gets blurry, so we're going to do 0.8. I did that joke on literally every other circuit board that I've created in the past 5 years. So I feel like getting away from that joke. So version 1.0 is just going to go like that. Paradoxically. Why didn't he screw up the version number? Why isn't it version 1.0.1.2 final, parentheses 1? No, we're not doing that joke. All right, version 1.0. So we got the version on there just for fun. Got all our traces down and everything. I'm going to save. There are tutorials on how to do this, and I may want to just follow a tutorial because I haven't done this in so long. But for outputting the correct files, excuse me, we need to output a particular cluster. How goes it? Things are going well. Got a headache. I feel like I have cat allergies. I didn't sleep last night. You know, the usual things. All the usual things. Here, let's update our board just so we can see the markings on there. And then it's basically just choosing Seed Studio from a pull-down menu. I don't know if anything has changed at Seed Studio or if they've taken that functionality out of Fusion. I think they have it in kind of like an archived thing. And I don't know if the Fusion Eagle service from Seed Studio has updated their capabilities at all. I think we'll get away with it, just outputting it using Fusion and then it'll just poop out the right. Where did it go? There it goes. Whoa! Smith Clay, thank you for subbing for 53 months. Where did what the? Zoom out once. Okay, there we go. Thank you, Smith Clay. I really appreciate that very much. Yeah, so we got version 1. We have our chef's hat. Powered mult. The stripe marking. Just for funsies. Also a positive marking. Kind of feels like I could have moved these up a little bit to clearance the plug. But those will clear the 0.1 inch headers. It's when you finally get to look at the design like this that you realize, like, oh, I guess I could have spaced this out a little differently. Yeah, I'm pretty allergic to cats. I love cats, but I'm pretty allergic to them. I'm not like Rich Evans allergic to them, but I do get like uncomfortably itchy eyes around cats. It's very annoying. I know how to deal with it. And there is a cat that we've seen in the neighborhood, a black and white cat. Oh, there we go. That's why we do this. That's why we do it. You won, sneaking in, trying to ruin our day. You. Save that. Evil kitty. I'm disappointed you're using typical component markings and not values. What? What are you talking about? My eyes swell shut. Oh my God. Yeah, you know, the roof of my mouth itches and my eyes are like puffy and itchy, but I don't know if it's a cat doing that. I've seen the cat in the territory where I walk the dog. You're just doing that to get me riled up, huh? I actually don't know what the value of these components are going to be because it's actually a sort of a, I've got the design. I haven't figured out the specifics of what components I want to use. Probably a lot of 100Ks. It's probably going to be 100, 100, and then 1K on the output resistor. But I don't know what those values are, so I couldn't even put them in if I wanted to. These are some form of picofarad, like 20 picofarad, and then the decoupling caps are going to be 100 nanofarads or 0.1 ohm. But yeah, we got conflicting parts conflicting here, but the CAD software will not pick up on this as a conflict. So we're good to go because the design rules were put in for laying out the traces in the first place. We can do a design rule check, and that's going to uncover some stuff that maybe the CAD software doesn't like, but would technically be connected anyway. We should run a design rule check just to make sure that we're within parameters. So we go into rules, and what rules do we have? Open up design rule tool. So we are in JLC PCB 2-layer. I want to be in Seed Studio 2-layer. FusionLibrary.io public. It's Fusion Electronics. Cover a wide range of applications. So we want more specific. Here we go. Fusion Electronics design rules that might be old, but DRU and E. Oh no, that's Fusion. Wait, what's going on here? They used to have, okay, hold on, let's try to find it. Yeah, these are all the design rules. You got to kind of go through it and like set them. Ugh, very annoying. But some places used to have the design rules by file. You can just download the file and then load it up. Okay, they've changed this. Oh, update active CAN job. There it is. So, new cam, open cam, recent cam. Hold on. Hey. Stop it. Templates. And we get layers, system examples, third party, Seed Fusion 2-layer. Bada bing. Now would this be board like a rule check? That's just a cam job. The cam job just tells it what needs to be output in what files. Solder mask, silk screen, copper, then drill layer. And we're not using assembly or anything like that. ODB, what is that? Copper layer 1 specifies in layer stack not referenced by ODB++ layers. Copper layer 16, what? Missing components. Layer comp plus top and bot. What does that even mean? My cam stuff is so old that I might want to go through this again. Component layer is not going to be at all important because we're not marking the components. ODB is the alternative to Gerber. I see. Gerber, baby. Let's see what Seed says for their Fusion stuff. I mean, I got a board ordered as late as recently as last year, but that was January of last year. So So, Fusion Guide. Add Gerber, baby. How much are you guys charging for this these days? 100 by 100. $9! This used to be $5. They added $4 onto this freaking service because of all this bullshit. Ah, sucks. Special offer. $10 for new customers. I'm not a new customer. Shipping coupon. $5. Valid for 30 days. So this is for 2 layers. This is 10 boards. I guess it was 5 for $5, so 10 for $9.90 isn't that bad. The shipping is what really kind of gets you over the barrel, though. Why aren't you using this thing or that thing that I like and want you to use? Because I'm using this. Yeah, it's I used to get that a lot. It must be that like people who know this stuff. ODB is an alternative. Oh, I already read that. It used to be like, you know, chat used to be flying, and there used to be a bunch of people watching my streams, and so they'd wonder why you're not using their particular pet CAD software. And that was a fairly common thing for me to hear. That's kind of calmed down. It's quieted down quite a bit. Isn't it by 10? It still fits, but curious why you like this one over the others. It's what I've used traditionally, and they used to be built into the software. You saw that it was built into the software that we had a Seed Studio output profile. Although it's old, so I don't know if that's quite still the flexible boards. $376. So yeah, definitely not getting flexible PCBs from Seed Studio. Yeah, then no assembly. Zip or RAR. Special requirements not available on this page. Minimum drill hole 0.2, trace width 4.4 mil, solder mass dam 0.1. I think if I use that, they're able to just do it. I think this is everything that I need. I don't need component placement stuff. Yeah, roll up Eurorack. That's a lot. Boo, Flexi is fun. Who does Flexi? I think JLC does flexible. Or was it Seed that had the super deal for flexible PCBs? Because that's where I was actually ordering flexible PCBs for the keyboard project, but that got the bosh as soon as all of the political nonsense happened. So export a zip. So let's just process this job, because I think we're following all the rules. We didn't really do a rule check though, just because I didn't put the design rules in there for Seed Studio boards. I'm too lazy. Let's do, you know what? This is filling me with trepidation. Cancel, cancel, cancel. Discard. Okay, first we do a design rule check. And you know, the design rules are already in there. I just need to make sure that they're right. I mean, 2 drill, component exclude. Where's my wire to wire? Is 0.1 in this one. A buddy got some decent flexies from them. Yeah, it's pretty cool to be able to order flexible PCBs. Copper weight, minimum drill hole size 0.2. Wire pad clearance, SMD clearance. Copper width 0.2, drill size 0.2, so we're at the minimum. Trace width spacing 4.4. Wire to wire. That's 0.1. What is 4 mil? 4 mil in millimeter. Okay, so we are a little bit out of spec. 0.1016. We live in cool times. Yeah, there's some cool stuff you can do. Got to figure out how to do a custom PCB carrier board to remove a bunch of wiring I have in 5 different components. Oh, I see, yeah. Turn it into a single board. Yeah. That's a fun one. Am I going to get away with that? Because right now my spacing is 1 millimeter. 0.1, which means my traces are infinitesimally closer than what Seed recommends for this size board, for this service. What is the solder mask dam? Solder mask dam between copper pads. This helps to prevent accidental solder bridging during assembly. 0.1 millimeter can only be achieved with green solder mask. If you use black or white, the minimum solder mask dam is 0.15. Okay, I don't know if we need to worry about that. Drill hole size 0.3. If I go to 0.2, it's $60. So I need to up the drill hole size. This is going to really fuck with everything, isn't it? Yeah, trace width and spacing is also going to really mess me up. 6 mil, how close together is that? Ugh. Well, thanks for sharing this stuff. I really appreciate it. Oh, man, hey, good stuff. All right, so my design just exploded. My design rules were set a little too loosey-goosey. Pad clearance is okay. Wire to via clearance of 0.1. They were saying it was, which one was that? 0.00, it's 0.016, yeah. Yeah, we gotta review this. This is gonna blow up my whole shtick, my whole deal. That's fine. Board outline, what do we, well, we don't know that. Hold on. Via restrict clearance, that one's doesn't matter. Drill of 0.2. That's not the drill size, that's the drill clearance. Drill size is 0.2. That's going to need to be increased. Hold on, let's just check what's our drill size here. This may push me to do JLC. That's 0.35. That's fine. Okay, that's our smallest drills, the vias, and that's at 0.35. For if I do insist on going with seed, which I'm very quickly starting to drift away from Seed Studio here. Minimum drill 0.3. Okay, we're in that spec. We're in that spec. Now the trace width / spacing 6 by 6, which is 0.15. So these are 0.2. So those are in spec. How close is that trace width spacing? This is kind of the important part. Right here needs to work. So back to the design rules. Where are we going? We're doing design rules. Pad clearance, via clearance, SMD clearance. We're not worried about that. Board outline clearance, via restrict, copper restrict. Clearance between copper and objects on the restrict layer. No. Unconnected lines. Copper width 0.2. Oh, this does teardrops? Oh man, I didn't do teardrops. I should enable those. Teardrops are fun. They help your little electrons get out of your thing. No, they're probably mostly aesthetic unless you're doing RF. Acute angle, nah. Wire stub, nah. Those are just checks to see if that happens. Match signal lengths we don't have. I don't know, I'm starting to think that this is fine. But what is, I mean, like, okay, so I'm trying to like define this in my head. Because this is the easiest way to blow up my whole design. Minimum space between traces in your design. If your design needs to be batch product, please ensure spacing is greater than that of 6 mil. So 6 mil, that's pretty big. But what do I need to do? Plated castellations, no. Mostly we are in compliance with all of this. So we can choose like a... I might get this in yellow just because it looks good. One design on the whole thing, yeah. And so this is just the big one right here, is that trace width and spacing. It needs 0.15 in between. Where do I specify that? Pad clearance? Checks the clearance between different copper objects, and we're at 0.15. So we are in compliance then. How close are we in compliance? Because it's an inch standard. Mil is an inch standard. It's so stupid. Mil, so 6 mil in millimeters is 0.1524. 0.0024 of a millimeter. Are they going to get weird about that? You know what? Maybe they won't. Maybe they'll just run it through the machine because I'm cool and they think I'm cool because they know that I'm cool. And so they'll just accept it. Because I think all the parameters are pulled over from this project and we didn't run into any of those problems. Although, yeah, we have a lot of traces that are in parallel with one another. And we're not having them check to see if they're good. So 0.0024 is not perceivable. Oh yeah? Oh yeah? Oh yeah? Let's put that to the test. I don't have enough digits. I don't have enough digits. Here's 0.35. That's 0.35. 0.35. 34, sorry, I got it wrong. So what is then 0.0024? No, it's too much. Less than that. You need to go further in. Less than that. I'm pushing on it. I'm pushing. There we go. There's 0.0024. I see. That's a big problem. See, the problem is the scale is just so mind-boggling when you design boards. Because they do have that precision, the sub-micrometer precision here. I mean, I have a micrometer somewhere. I'm not going to go get it. All right. So under the current design rules, it seems like we should be okay to have the board made. Let's do a design rule check. So rules, check design rules. Mostly what would 9 warnings, geez. Mostly what we're going to see is you might not want to do this, or there is a stub of wire in the middle of your wire. That happens quite a bit. So I guess I'm going to use the rip up tool to get rid of some of these internal things. Oh, look at that. The rip up tool has a lot of, let's go ahead and just highlight and delete. Look at all that. So this is just mess that's left over from the trace routing. Trace routing is really fun. We had a question about doing it manually because the viewer only used the auto trace router, which I generally do not use. I don't really trust it. I don't like the work that it does. I route my own traces and then I can do weird stuff like this. I don't particularly like this junction. That's not a fun thing. But when you do manually route the traces, you are of course clicking on these little air wires, and those air wires, when you start rearranging things and sort of moving stuff around and changing your intents and designs, they can tend to leave behind these weird artifacts. Okay. Hello? No. All right. Layers. Don't view the bottom layer. And then let's bring back these and get rid of this air stub. Because it wants the wire in the software to connect. Now, all this stuff here is underneath the pad, so it connects. It clearly connects, and it wouldn't it won't hurt the design at all. It might make it a little larger if there's some vector nonsense sitting underneath the pad, but in the end, like, that's just, you know, it's nothing. You're nothing. How do I highlight that? So we can come in like this. Nope. Control Z. The dogs are now barking at the people mowing the lawns. See, now there's an air wire. So we've got an air wire that's sitting inside of this thing. That's that little semicircle right there. Those are what define what connects where. So if I get rid of this whole stub, you see that? Now we've got this line here that says, hey, you have not routed this trace yet. So I can go to the properties, and we are a 0.4 millimeter wire. So I go to route, and then I do not 2.54, 0.4. Oh, that's corner radius. Wait, whoa, whoa, whoa. Wire, not minimum. I want 0.4 millimeter. And my dots aren't working. Dot. There, okay. And that goes from here to there. So now I should not have a stub. I don't. Okay. Bottom layer. That's really all these corrections are doing. They're just getting rid of these little like stubs that are mistakenly in there. It wasn't centered on the part. No, because it was up here. These are centered. Oh. Ah. Did that leave behind a little tiny air wire? It did. I guess it doesn't care about those. Wire stub as the whole thing? What happens if I delete it? Yeah, what size are you? 0.2? 0.2. Oh, it took my 0.4. Wait a minute. Put that back to where it was. There. More wire stubs. Okay. Air wire. This is the one that we did before. Yep. A tiny little air wire is enough to set off alarm bells in the software. So I'm just going to take a 0.2 under the pad where nobody can see and connect it to the green. Why is it not letting me? What is this? What is this crap? There. All right, 0 errors, 0 approved, no errors at all. We're done with the design rule check. That was like, none of that was necessary. None of that would have like improved my design in any meaningful way. That's sort of what it's like with these newfangled pieces of software that do all your homework for you and, you know, tousle your hair just right. I probably should flip the position of these two. I don't know why I didn't see this before, but if I flip the position of these two, then this stays the same. This gets shorter. It doesn't matter. They're all like that. This is going to bug the crap out of me perpetually, that I really should have flipped these two. I'm not going to do it. I'm not going to flip them. I really want to, but it means I need to redraw all these traces, and I don't want to do that. It does bug me though, because it's like, what changes here? It's just that the path would be from there, and I could also flip this one, and then they would both be on the same side for that signal. Oh no, but that needs to get around to it. So I know it's like, it's these little, I gotta just put my foot in my mouth and just not do it. Don't do it, man. But it's like the trace layout would be, no, 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 no. Get away from it. Step away from the computer. You're done. Put the computer down. That looks real ugly. I think it smooths it out when you go to order the board, because like that's, wow. There's all kinds of conflicting like fills that are going on there. And I think I have those on the right parameters, right? Let's check. No, isolate. 0.1524. Oh, 1524. Yeah, that's 6 mil. Okay, cool. Not hatched, no orphans. Yeah, okay. So the Seed Studio settings were already in there. That probably should have been the first thing I did, was check all of those design rule settings, because as you design the board, it applies all of those things. Willow idea. Oh, it's like, why is this lighting up? Why am I being distracted? Momo's gone. Momo has been delivered to the client, who's Big John in chat. Momo's been delivered to the client. There's a couple little wiring things that need to be put in. And from there, I mean, it's just ready to go. So that'll be cool that my friend gets that back. This is now complete. Our powered mult, once more into the breach, functions perfectly. This is the problem with streaming, is that you may think that your stream is going to take the full 5 hours, and you get it done in 35% CPU. Wait a minute, no, 3 hours and 15 minutes. At least we got to the 3 hour mark, but I really should be doing 4 or 5 hour streams. Not that anything is holding me to that. Did this update? Okay, it's working on it. Not that anything is really holding me to that. A lot of these streams have been a lot shorter, but I don't want you guys to like be strung along. I can tell when streamers, and sometimes, you know, it's charming when the streamer does it. They go into their little anecdotal explanation space. You can tell their speech changes and they're not actually playing the game, and they just kind of sit there with the thing steady and tell everyone a story. You can tell when a streamer's doing that a lot to kind of draw out content. But yeah, we've taken this board, we've designed it based on a size restriction on Eurorack modules. I've put all of my appropriate identification text on it, calling it the powered mult, 73026. We've got Twitch TV Bother on there. I could probably put that down here, but I want it to not interfere with these resistors on the sides. And I have kind of like a de facto standard for designing Eurorack modules in the 2 HP form factor. 2 HP is really popular because you can put a lot of stuff into, you know, your rack. You can have a huge variety of different things. So as we stumble across circuits that I like, we might be able to come up with some of our own designs, and then I can spin them out in 2 HP flavor pretty quickly with this design. This design took about 2 days of work, and it was pretty easy work, just doing the Factorio thing where you're trying to fit all your traces in. All of that would have been completely and utterly ruined, and I would have been in shambles if I had not already had Seed Studio compatible design rules in there. We might have had to go to Osh Park, because I think they let you get a little closer, or JLC or Osh Park, because they let you get a little closer, but I think they're a little bit more expensive. But this will work out. The only way that I don't see this working out completely is if the power plug doesn't plug. If the power plug is too close to the edge. I'm not really sure how I could get it further from the edge. This is all I have to work with for getting the power plug to fit. So I guess it's what it's. This is just what you got to deal with. But it'll look something like this. It'll be nice and organized. All the parts will be on there. I'll have 2 absolutely enormous tantalum capacitors, helping to kind of boost the voltage in there. Tantalums are a little bit fragile for this, but yeah, this is a PCB design with Fusion 360. We're not using KiCad. If Fusion 360 had not provided me with a copy of their software for free, I would be using KiCad at this point. I don't know if the free version would be able to keep up with me, and there are other restrictions on like the free version of Fusion doing PCB design, they've sort of unrestricted the like file storage stuff so that you can store a lot of these 3D models for components. But I don't know much about it because I don't use the free version. So, but yeah, that's the powered mult. I'm going to get 10 of these PCBs. It's about $1 in chips. The capacitors and resistors, I don't really know what those would be. This would be very little. It's a chef's hat. What are you talking about? I don't know what you mean. This is a chef's hat. Hopefully the performance of my powered mult is going to be up to snuff. We have sort of flirted with noisy signals by putting these so long in parallel. This is not good. I would like to have a little bit of ground in between these traces, but I cannot help it. I could, if I really wanted to, eke this one down and I would get a little bit of stuff in between, but we'll see, you know, on audio level signals. I don't know if we're really going to be producing that much noise that transfers from trace to trace, especially with the 6 mil restriction keeping us so far apart. So, and if it works the first time, that'll be a bother first, but I suspect it will work. The circuit is very easy and repeated. And so once I put this all together, I will make 10 of them, and then I will make it rain on my friends and keep like 5 of them for myself. It'd be a holiday gift to my buddies. Cool. All right. So now I guess we just output the files, and then the files get uploaded to Seed Studio's website. One thing you can do is you can get an online Gerber viewer, and you can view your design files on a separate piece of software. That's being a little careful, but it does also clear things up pretty nicely. But anyway, I'm going to manufacturing, and I'm going to do the CAM processor. There's also a CAM preview in this software. Why you would do it in its own software, I understand why they would include a CAM viewer. The CAM job is a bunch of files that tell machines how to build your circuit board. And so you stack up all those CAM files and you take a look to see if you're not providing them with something you shouldn't be. So what I'm doing is I'm running I guess OB+, but we're doing not the template. We're running system examples, third party, Seed Fusion, Seed 2 layer. So ODB being the alternate software, I don't know what's going to go on with that, but I guess we're just going to make a regular old Gerber file. We don't need assembly, we don't need drawings or legacy files at all. So I am just going to run this. This is going to output to, I don't know. I guess it'll pull it up. It'll export as a zip. Process the job. And so that's going in desktop temp prints. I guess that's a place to put it. Save. All right, and so now the temp prints folder. The current CAM job has changed. I don't save it. Seed Fusion 2 layer. Yeah, sure. Okay. All right. So now in temp prints, which is that on this? I don't know what part of the desktop it's on. Hold on, we've got solutions for this. Just do this. Go to desktop. It's easier to browse the desktop like this. It's like I should be using Linux and then not have anything on the desktop, and then I would have a folder that I'd be working out of. But no, I have to do it this way. So I guess that's just saving the CAM job. That's weird. Powered mult 2026 730.zip. Don't look at that. I paid for WinRAR. So bottom layer, bottom outline, GML, GTO, et cetera, et cetera, et cetera. All of those are just right here. I don't know what Penn Island is doing. What's Penn Island doing there? Gerberjob.gerberjob. What the hell is that? I don't think that is necessary in these files. I think we just need this stuff. All of these. Whatever I'm saying, I probably mean other things. Yeah, sorry. I don't often refer to stuff as the right thing. Gerberjob.gerberjob. What is that file? I don't know if I need that. I think if I send it all to Seed Studio, they'll tell me if they have problems with any of this stuff, though. Really, these services, they just throw it into the machines, and then the machines will take all the files and batch it up with a whole bunch of other PCBs, and then poop it out. And if there's any errors, then, you know, a little light comes on a console and somebody reviews it, and they'll send an email. So they'll knock you out of the batch and then resolve any of your stuff after the fact. These are basically big, long machines that you put files into one end and PCBs are sharded out the other. Hey, we got a raid! What's going on? E to the 2 pi with 13 individuals. What a lucky raid. How you doing, E to the 2 pi? We are finalizing our design of a modular synthesizer module. What is responsible for powered mult. A powered mult is a device where you have an input and multiple output. How's the engineering today? It's mostly visual. Most of what we're doing is doing design rule checks and just making things that look good on the PCB. Fusion 360 does a full rendering of even the traces have a little bit of depth to them, depending on how you set the settings. And so we've been able to clean up all of our markings and put all of our appropriate markings on the board. We've run the design rule checks, which are, by the way, fundamental to when you design the board. It's like the software itself is keeping your traces a certain width apart. So if you put the design rules in early and you just design your board as the software will allow you, you should not have any errors in the design rule check. The only errors we had were little bits of traces that were under pads being a little bit wrong, and it was kind of stupid. But yeah, we got a version number on it and everything, and now I am ready to pretty much order the powered mult. The powered mult works in that if you plug one input into the first plug, it will repeat it on the next 3, skipping the input, and then on the next 3. If you plug 2 separate inputs to the 2 separate inputs, it will repeat it on the 3 below it. If you plug in the middle plug, it will go to all 6. So both of those can go to both banks of amplifiers, or each one individually can go to its own bank of amplifiers. And then just for funsies, we have LEDs on it too. I have a green and a red. I decided to do 2 LEDs instead of 1 dual color, probably also because all I can fit here are these. The dual color might not fit there. We might do something with light pipes, or I might just put a hole in the front panel to show this. But the red light comes on when the signal goes negative. The green light comes on when the signal is positive. That's what the 4th amplifier on each of the TLO74s, or whatever amplifier I choose, does. So 3 of them do the input to output, and then that 4th one does the LEDs. Relatively simple design, lots of repetition, and the 2 HP, 2 horizontal position requirement has put quite a bit of stress on the design. These are always a little bit difficult to put together. Big power supply, big capacitors, and then out to all of the amplifier banks, and a nice little orderly repetition. One thing that drives me absolutely bonkers is that this could be a shorter trace right here if I change places with these 2 components. I'm not going to do that. I decided not to do it. It would be about 20 minutes of work. I'm deciding against it. I'm not going to do it. I'm going to do it. I'm going to do it right now. I'm going to do that. I'm going to fix it. No, I'm not going to fix it. I'm not going to fix it. I'm not going to fix it. I'm not going to do it. I need to do it right now. I need to do that. No, I'm not doing it. I could probably have arranged these a little bit differently and they would have made more sense. I spent so much time worrying about it, and it's always at this point you go, well, maybe I could. Nope, not touching it. Nope. Okay, so that's all set. Our board is ready to order from Seed Studio. I'm going to save. I'm going to hit save so many times that my S key blows up. It actually physically explodes. And then I need to order it. So do you guys remember what my credit card number is? Can you guys let me know what my credit card number is, please? But yeah, that's the fun part. I mean, designing a PCB is fun. Like, it's fun. It's got a 3. Oh, good. Oh, thank goodness. I'm glad you guys remembered that, because I wouldn't have. Yeah, pulling all of the D's and the R's and the C's off and making a board that's 2 HP. I can now spin these out with pretty good regularity. Oh, those are some of the numbers? That looks a little bit out of order. I think that is out of order. 8675309. Oh, I didn't hold that note very well. 8675309. I'm singing it in kind of a flat. You can put anything on circuit boards. There are no rules. Well, I don't. It would be kind of interesting to figure out what you could put on the circuit board that would get your circuit board producer in trouble with their own government. That would be kind of mean, because I kind of like them. Yeah, we've got this Thursday, it's hovercraft racing. That's a Four Seasons Total Landscaping hovercraft team. They're not having political rallies at their whatever, their paddock. What do you call that? It's their home base, I guess. I don't know. So they're here. This side towards enemy. No, I was thinking like Tiananmen Square stuff. Oh man. Oh boy. Or if if it was like Osh Park, you could say all kinds of free speech stuff. Oh man. No, I'm not. That's mean. I like Seed Studio a lot. They produce very nice circuit boards. So I am going to be getting my powered mult. And if I really wanted to, I could pull this in as like, we could actually design a cool logo and pull that in on the silk screen. It would look better if I chose like the font and made it look cool, but I'm not going to do that. I think just two text sizes on top of one another is a good way to do it. Okay. That's it. That's it. We're done. I'm not changing anything on this. This is a revision now. I could probably say that this is a final design in the software, and that would lock this out. And so I wouldn't be able to make any changes on it. And then I'd have to spin off another version in order to do any of the corrections that may surface when we actually get the board produced and I attempt at building it. This is simple enough that I don't think I'm going to have trouble. We've got ads in 30 seconds, so bear with me for 30 seconds. I'm going to talk about BS while the ad runs, and basically everybody here is just going to listen to the dulcet tones of the lawnmowers. Speaking of lawnmowers, I got Momo out. Momo's at John's now. And Momo appears to have worked perfectly fine. We'll wait for an update from John. In the future, what day is tomorrow? 31st? We do have a 31st. 15 days past November, April Fools and December, but then there's 31 on the unfun one. I don't remember that rhyme. I don't remember that rhyme properly. Oh, good. Now my hay fever is going to act up now that they've antagonized all the grass around me. There's the ad. The ad just started. Advertisements. Pre-rolls are disabled for 63 minutes. That's actually pretty generous. Yeah, E to the 2 pi, thank you for the raid. That was really cool. 13 viewers, very nice of you. Kisa the Immortal Slab, I missed. That was a 15 stream streak. Oh, I don't know if I need to really... I guess I'll read them. I don't have much to read these days. We got a hype train going too. That was neat. And that was 45 minutes ago. Smith Clay. And then Code Rushed with 8 viewers rated. And Go Slab 20 was at a 3-stream streak. That's very cool. I'm glad you guys enjoy these streams. 17 months, tier 1, what was that? 3 hours ago. So this Pseudo Maze, thank you so much. Blimey's was 2 days ago. Okay, so that's today's activity. 4 things a stream happen. 4 or 5 if we're lucky. We got to go back to the air raid siren. All the parts for that are sitting behind me, and I've got 2 motor controllers for drones that are ASM. What is it again? It's the whatever. It's the like. I think I need to plug it into the like Google Chrome in order to program it. And if we can get them running on sine wave mode, that means they'll run quietly so that we're not listening to that cogging sound that drone motors make. We can get rid of that with one of the settings, hopefully. So we'll have to test that. They're much smaller. They say they're 40 amps. They're like this big. They're like that big. but they're 40 amps, whereas the controllers that John had were like this big and 40 amps. I guess they go in reverse and they have Hall effect sensors and stuff too, so they're more crazy. But they might be 4 amps, I'm not sure. Got to get that number, yeah. This one has more number than yours. It's, well, but the motors then become the limitation, you know. That's why my buddy John is running his 2 amp motors on a 40 amp controller, just because all of that overhead hopefully means that the FETs aren't going to like go and then die. Also, they came with heat sinks, I think was his primary thing. Ad break ends in 3 seconds. Bonk. Hey, welcome back from the ad. I apologize for the ads, but I do want that discoverability. We'll run that for a little bit, and then I'll get annoyed with it and disable it again, and we'll go back to pre-roll ads. Okay, we designed a PCB. We got it done. So we're going to order it, and then in like a week or two, it's usually like 2 weeks, I think, to get to America. We'll get it in the mail, that or they'll send ICE after me and beat me to death with a club. Either one could happen. It's a 50-50. So we'll see what happens when I go and order PCP. Oops, PCP. Oopsies. No, I don't do drugs on stream, man. Could you imagine having the mental faculties to both be completely off your gourd and stream? I couldn't do it, man. I couldn't do it. Bother needs a nap, but before that, Bother needs to walk 2 corgis that are going to be juxtaposed in their directions. I was very angry yesterday that the corgis would not walk, because Willow doesn't want to go anywhere, and Quillen wants to just walk around the whole circle of the neighborhood. And so I end up either being mean to Willow or Quillen, and they're doing it to one another, but I'm the conduit through which they give their pouty looks. Yeah, Quillen is the corgi with the big tail and the big face. He's our neighbor, a former mayor's, the former neighbor's dog. She moved away. And some people in the neighborhood seem to have trouble with the conceptualization that a person may have friends. So when they see this neighbor that moved away in the neighborhood, they go, "What are you doing here?" And it's like a little mean. It's like a little mean-spirited. Like, "I thought you moved away." It's like, yeah, but I made friends in the neighborhood. Like, the dog people are tight-knit because we always see each other outside, and the dogs love saying hi to each other. But it's like, it's so weird that people would be that rude. But anyway, so our neighbor occasionally needs help looking after the dog, and so they drop off the corgi here. Quillen's about 4 years older than Willow. That lit up the light. I assure you, this should be in a better position where you can see it a little bit on that camera. Maybe I'll put it right there. Yeah, see, now it's something that actually activates. Did it power down? Did I accidentally knock the cable? What happened? Hold on, let me try it. Yeah, there it goes. Anyway, so yeah, Quillen is a little older than Willow. He is a little bigger, but Willow weighs more. She's fat. My dog's fat. We need to lose weight. But yeah, having them here is really fun, except when you take them for walks and then they both look at you like, "How could you do this to me?" And it's like, guys, I'm trying not to get hit by a car in the middle of the road while one of you pulls me in one direction and the other doesn't move. So I gotta go do that. That's what I'm gonna be doing in the next couple minutes. I'm gonna be on the Discord. That's pretty much my social media at this juncture. I had X for a while. I had Twitter for a while. Then it turned into X and it was filled with a bunch of horrible people, but the Japanese like maker community Twitter is really cool. So I have had an internal debate about whether or not I want to go back to Twitter, but I don't really want to. I think in the end, unfortunately, I'm just going to be cut off from those zany makers over in Japan. I had Blue Sky, but it got hacked and sent a bunch of porno invites all over the place, and then got shut down. And now they don't really do anything with my emails about it, so I don't know what to do there. But if you're interested, I'm on Discord. That's the one that I primarily use, and it's a relatively quiet Discord. we've got a decent number of people in there that don't watch my streams anymore. They're not here. Where are they? Yeah. So anyway, I'm going to be walking dogs, and I'll be on Discord, and I'm going to be back tomorrow, and we're going to figure out what to work on. I think we need to do a little bit of a troubleshooting session with some of these modular synthesizer modules, or I pull out one of these other projects that's been irking me for some time. We also need to begin assessing some of these filters that I bought. Filters and effects and things like that. So there's one that uses a lot of the chips that we used on today's project. Oh my God, I keep hiccuping. Thanks for streaming. I keep like, I gotta fix those emotes so that BTTV goes in there. I'm gonna have to look that up in the near future, but yeah. Okay, anyway, thank you for joining me. Really appreciate you guys very much. I will be back tomorrow. We'll do cool stuff.